can be applied to visualization in public spaces.
Do these three essays construct their argumentation similarly? Where in this table of argumentation data from the previously seen texts can I find certain argumentation patterns? Do these three argument maps depict the same argument? We have developed a visual analysis system for argumentation in essays that can answer these questions at a glance. You want to know how it works? Come to my talk.
We demonstrate that people can use the spatial cues available in virtual reality to help them effectively remember and recall scholarly articles. We used a virtual coffee shop and asked participants to remember 4 abstracts from scientific publications, and we termed this method a virtual reality memory palace variant.
We present a method for real-time ray tracing of stream tubes for fluid flows and diffusion tensor MRI. Rays are traced through a sparse voxel lock tree until they intersect leaf nodes which contain tube segments. This checkerboard pattern indicates voxel boundaries. Within leaf nodes, we can ray trace straight tube segments or ray cast curved tube segments.
Data videos are quite popular nowadays. They usually show changes in the data. However, creating a data video requires multiple skills, and the process is usually laborious and iterative. Our approach focuses on automatic and interactive visual enhancement of important changes in time series data with data video.
This is a picture of a Tableau visualization within the browser. The data behind the visualization does not exist here, and Tableau is not running. This is just an image. However, parts of this image are fully interactive. Please join our presentation to see how we can share interactive visualizations across the web, free from any dependency on data or visualization application.
Program developers spend significant time on optimizing and tuning applications. But working with binary code to understand what compiler optimizations were applied can be challenging. We present our visual analytics system, CCNAV, designed to identify and assess compiler optimizations in binary code. Check out our paper to learn more.
Morse complexes have shown a great utility in understanding the topology of complex scientific datasets. The noise in the scalar field, however, can significantly distort the Morse complex topology. Hence, we study the extraction of Morse complexes for ensembles of noisy scalar fields through their uncertainty visualization using our proposed statistical summary maps.
Magnetic reconnection is a ubiquitous and complex physical process that occurs throughout the universe. Locally, this process is observed when the solar wind interacts with the Earth's magnetosphere, causing magnetic field lines to break and reconnect. One of the results of this process can be seen from Earth as the aurorae. In our talk, we introduce scalar field topology as a method to identify and analyze features in 2D magnetic reconnection simulations.
DVR has always been from considerable interest to the scientific community. To this day, traditional desktop setups are the gold standard. However, what if we could utilize DVR in virtual reality? Now you think, VR and DVR are so computationally expensive, how is this even feasible? Come to my talk and we present you a straightforward solution to visualize volumetric datasets with high refresh rates on VR devices.
Ray tracing techniques can create images of astonishing realism and beauty. In the last years, the performance of those techniques has been increased significantly using dedicated hardware. Who thought that it's also possible to accelerate this? We show how to dramatically accelerate force-directed graph drawing with RT cores, yielding a speed up of 4 to 13x. If you want to know more, please see our talk.
With the proliferation of AutoML systems, it's now easier than ever for non-experts to create and deploy end-to-end machine learning pipelines. These systems explore the model search space and optimize hyperparameters in order to solve a particular task. We propose Pipeline Profiler, a tool that enables the exploration and comparison of machine learning pipelines produced by multiple AutoML systems. By analyzing these pipelines, we have the opportunity to better understand how AutoML systems work and obtain insights that can be used to improve them.
We asked participants to recreate bar graphs. When the bar was alone, we saw a different pattern of error than when the bar was presented with context in a stacked bar graph. We find that absolute error increased for higher bars when they were presented alone. We also found that there was a bias in the responses such that they were repulsed from an implicit 50% mark. We found a magic number, 10%, to predict error. Participants are usually within 10% of the height of the bar.
Linking and brushing is very useful for interactive visual data exploration. Data-driven brushing tools are getting popular recently and achieve good results, for example the Mahsan-based brush and the CNN-based brush. However, these brushing tools are optimized by the data from a large number of users, which are not suitable for everyone. In this paper, we introduce an adaptive brush model which takes the user in a loop to improve the brushing accuracy.
Hurricanes, air pollution, forest fires, urban sprawl, ocean plastics, politics, traffic jams, and pandemics. So many of our modern challenges are geospatial, and so much of our big data is geospatial. How is the VIS community addressing needs to visualize and analyze this data? Our review examines IEEE VIS's recent contributions to geovisualization and geospatial analysis.
Imagine you have tons of text data to analyze. And you want to get an overview of your data, but traditional topping modeling techniques such as LDA are not working for you. Then, why don't you try Architext? We introduce a scalable and flexible way to interactively build hierarchical topics.
Out-of-distribution samples refer to the test samples not well covered by the training data, like these black cats. They are misclassified with high confidence due to their black bodies. To explain why these samples are out of distribution, we developed OOD Analyzer, a visual analytics tool which provides an ensemble detection method and a grid-based visualization to detect and analyze out-of-distribution samples.
CarXS is an authoring system which enables rapid creation of zooming-based scatter plot-like visualizations in just tens of lines of JSON. We contribute a declarative grammar for such visualizations, which captures a large design space. By working with multi-node database spatial indexes, CarXS enables interactive browsing of billions of data points. Come listen to our talk to learn more.
Tableau helps you see the stories in your data. It's designed to help you be smarter, so you can make better decisions faster. Connect to the data you care about. Sort, highlight, drill down, or filter your data in seconds. Add calculations to extend your data. With Tableau, you can keep on asking questions in the data until you discover the root cause. Tableau, answer questions at the speed of thought.
When developing a deep learning model, people typically struggle to optimize hyperparameters that affecting the model performance. To relieve the pain of this manual trial process, AutoML has been developed as a solution. However, to maximize the potential of the AutoML, people should identify a good AutoML setting for their task. Hypertender helps to maximize the potential by visualizing AutoML algorithm behavior and guiding effective hyperparameters.
We present a flexible and easy-to-use software infrastructure for interactive rendering of large-scale display walls, either from on-site or from remote cluster. The display service can easily be configured to support a range of typical network and display hardware configurations. The client library provides a straightforward interface for easy integration into CPU and GPU renderers. We also demonstrate this framework for use in deploying low-cost alternatives for display walls.
CMed is a visual analytics framework for exploring medical image data annotations acquired from crowdsourcing. CMed can be used to visualize, classify, and filter crowdsourced clinical data based on a number of different metrics such as detection rate, logged events, and clustering of the annotations. CMed provides several interactive linked visualization components to analyze the crowd annotation results for a particular video and the associated workers.
Due to the lack of efficient tools, traders rely on the memory to manually compare the algorithm instances of a trading algorithm. We work closely with the industry practitioners to discover the user requirements and develop a visual analytics system, Goodall, for trading algorithm optimizations. Structured expert interviews are conducted, and a representative case study is documented for illustrating the system effectiveness.
Billions of biologging records reflect animal behaviors on many temporal spatial scales, yet segmenting the time series on multiple scales is often avoided or impeded. Hence we present our MultiSeg VA platform with its 3 contributions. First, MultiSeg VA contributes tailored visual interactive features for multi-scale segmentation. Second, we show a new visual query language to flexibly configure scale-wise techniques and parameters. This VQL consumes a domain-oriented set of techniques, our third contribution.
In a visualization, laying out labels to data points needs to be done automatically with a fast labeling algorithm. We introduce occupancy bitmap. It's a data structure that helps the labeling algorithm to, first, quickly record the positions of existing marks and labels, and second, quickly detect overlapping of labels to the recorded positions.
Hi everyone, my name is Mahsan Nourani and I am very excited to welcome each and every one of you to TREX 2020, the first time workshop on trust and expertise in visualization systems. I am a fourth year PhD student at University of Florida. I've been one of the organizers of this workshop and today I'm going to be one of the session chairs as well. Although we thought that this workshop will be in person in Salt Lake City and we wanted the discussions and conversation to be two-sided, we still want to make sure that that happens. And thanks to VIS, we have the enough technical support for that. So please make sure to use the YouTube live chat and also the Discord channel to ask questions, leave comments, even get to know the other members of the audience. We really want to keep the discussion going. So thank you for supporting us. I will be available throughout the VIS week on Discord to just keep the conversation going. But afterwards, you can reach me through my email, and I'm also on Twitter, so let's connect there too. I just wanted to, in the beginning of this introduction, I wanted to give a little bit of history of why TREX happened. And so in order to do so, I want to talk a little bit about my research. So I personally work on visual support systems, decision support systems that are powered by machine learning and AI models, but I take a human-centered perspective on these topics. So over the past few years of my PhD, I've been focusing on topics such as trust, domain expertise, different cognitive biases, and within different contexts and systems like explainable AI systems and visual analytics tools. Throughout this time that I've been focusing and experiencing these things, I realized that machine learning research and ACR research has kind of different views on the subject. In machine learning research, the people try to increase the algorithm goodness by increasing the performance that are measured through the performance metrics, such as the model accuracy. So if the model accuracy or other performance metrics are high, they would expect the system to be great. On the other hand, when you give the system to the users, they're not familiar with that, those performance metrics, and they have to experience it through time to be able to build a proper mental model of the model. So in an exploratory context and scenario, you can give the same system to two different people, but they kind of start having and building different mental model and understanding of the system, which can be very challenging and tricky. So in our recent Calibrating work, we did an exploratory task. We defined an exploratory task in a user study for users with, and we controlled the order in which users saw those tasks and kind of tried to complete them. So by controlling the order, we kind of influence how or in what order they observe the system errors and weaknesses. Our results actually showed that those people who are exposed to errors in the beginning had problems building the proper mental model of the system, and even oftentimes underestimated the system accuracy. On the other hand, those users who were exposed to system capabilities in the beginning had a better time forming a proper mental model. So this is people were exposed to the same system, but they had different impressions of the same system, which is, it's weird. But, one of the goals of XAI systems is to add explanations to help improve mental models. But here we can see in our study that the effects of the bias that is caused by first impressions is so much and so high that it cannot be bypassed by explanations. I kind of continued this trend and this research in another work that I also published recently in HCOM 2020, and I was looking at different systems that are used by different users with different levels of domain expertise. And I want to see if users are exposed to errors in different times during their interactions, how would they calibrate their trust over time? So with the experienced users, we observe an interesting trend where those who were exposed to errors early on, they didn't trust the system in the beginning, and they had a harder time to calibrate their trust over time. Also, some of them even mentioned they're not going to use a system in the future. On the other hand, those who were exposed to system capabilities and correct predictions in the beginning, they realized that they can actually calibrate their trust. They basically calibrated their trust based on what they observed. And these are just two examples of the research I personally did. And I know there are different work in the community that have been worked and focused on some of these topics, maybe separately, but I felt like there is a lack of connections between these topics, and kind of trying to tie everything together. And this is a reason that I feel like there needs to be this conversation. I wanted to encourage this conversation so that different people from different communities like psychology, HCI, visualization, or machine learning come together and try to see, like build a mental model of these topics together and how they're connected. And maybe this can help with the future research as well. And I'm really excited that other people have already shown interest in this. Especially, you're going to see great presentations today from the great papers that we got accepted in our workshop. There will be 3 awesome invited speakers that are coming from both academia and industry research. And we're going to have in the end of each session, we're going to have discussion panels that we're going to address some of these issues and talk about these things. So yeah. I'm really happy to have started this conversation, and let's get this conversation going. Just before we continue, I would like to give acknowledgement to the other organizers of the workshop, Eric, Aritra, John, and Kristin. Especially, I would like to give a shout out to my advisor, Dr. Ragan, who without his support and all of the support and the discussion we had together, I don't think this workshop would have happened. So thank you, Eric. Also, I would like to thank VIS for being there for us throughout the way with the amazing tech support. Especially, I would like to thank Will Usher and our amazing student volunteer in the chat, I think Ali, and also Kirian, who is our technician today. So thank you so much for supporting us. And last but not least, I would like to give a huge thanks to my other co-session chair and the other organizer of this workshop, Dr. Emily Wall, who is going to introduce herself in a second. Thank you.
Yeah, thanks, Mahsan. So I'm one of the workshop organizers and session chairs. I'm currently a postdoctoral scholar at Northwestern, and my research involves developing techniques to detect and create awareness of biases that are unconsciously driving people's decision-making with visualizations. So I'm going to be starting at Emory University as an assistant professor in the CS department next fall. So as a shameless side note, I am looking for graduate students. So if you're interested in joining me in Atlanta, then please reach out. So without further ado, let's kick things off. So it's my pleasure to introduce our first invited speaker, Steve Franconeri. Steve is a professor of psychology at Northwestern, where he directs the Visual Thinking Lab. And Steve's lab works on topics related to data visualization, perception, and attention. And he has a number of papers throughout the rest of the week on a variety of topics. So my favorite is one about replacing all charts with scatter plots, because as we all know, in Viz, precision is king, right? And literally the second half of the color and perception session is all work from Steve's lab as well. So keep an eye out for a lot more of Steve's work throughout the rest of the week. And today, Steve has prepared a talk for us about our totalitarian brains. So please take it away, Steve.
Okay, you can hear me? Thanks. Hi, everyone. I'm here to tell you a story of warning about why you shouldn't trust your totalitarian brain. So let's go to an analytics display. This is a display that was shown last year at InfoViz. This is from Emily Wall, John Stasko, and Alex Endert. This is a sample display that you might use to vet potential job applicants. In the upper left, you have a scatter plot with every applicant getting a circle. And on the upper right, you're going to have some filters that you can use to look through these potential applicants. You've got gender up on the top, and then work experience and education level. And in a display like this, we have to worry about bias. We have to worry about whether you trust your own brain, let's say, to fairly evaluate both the male and the female candidates. So today I'd like to give a little bit of a background from the cognitive science world about why we should be wary of trusting our own brain. Even a well-intentioned analyst is going to be biased. I want to give you a sense of why human brains can be so biased. So in order to show you that, I need to back up and talk about the brain in general for the moment. So your brain is a powerful neural network made of meat, and that meat takes a long time to develop. So after a lot of long-term experience, you can do some really amazing things with that network. Let me give you some examples. Y'all probably haven't seen this view for a while because you haven't been getting on as many airplanes, but I know whenever I get on an airplane, I take a look off to the flight deck and I marvel at the complexity of the displays that the pilots are using. And they can handle this because they've spent hundreds and thousands of hours staring at these displays. They've found ways of having little detectors in their visual system that respond to different kinds of gauges and meters. And then they organize those detectors into little panels that'll have some collection of gauges and meters. And then there's panels that are a superset of those that'll maybe help them land the plane or have the plane take off. So it's a really amazing hierarchy that they've built up in this long-term neural network that allows them to understand and represent the information that's shown in those displays. Chess experts will do something similar. So an expert will be able to look at a board like this, and they can immediately evaluate whether which player is winning this game. And they can already make predictions about what kinds of moves would be appropriate next. A chemist is going to be able to look at a molecule like this, and they can represent the individual atoms, small clusters of atoms, maybe noticing a carbon ring. And they even have existing entries in their brain for the entire configuration of these atoms to know that it's a caffeine molecule. If you're a physicist, you have little networks that have been built up slowly over time to tell you what the little bits of this equation are. And you can tell that there's some exponentials and some deltas. And you can even look at it holistically to be able to tell in general what this equation is saying. I can't, this thing just melts my brain. I can't do much with this. This is all depressing me because I don't have those kinds of expert networks. I can't handle these displays. So let me go to a task that I feel like it can handle. Bird, I can do that. Okay, I have long-term experience in recognizing objects, and so I have a well-worn network for that. And I can do that. And you know what? I can do that so amazingly that if you show me a rapid stream of pictures, at maybe only 20, 40 milliseconds a piece, flickering by right where I'm staring, I can recognize a bird versus flowers or vehicles or scenes. I'm going to be really good at that. In fact, here's a paper that actually tested that task. How fast can you recognize these complex objects? And if you look at the data, you can see if you flash these photos by really quickly right at where I'm looking, then I'm going to be at, let's just say 100% accuracy. So not only can I do that, but this network is so powerful that if you give me a second stream of pictures off in the periphery, and you flash that by at the same fast speed, I can also handle that stream of pictures at the same time. So that's how powerful that visual recognition network is going to be. But developing that network takes time, all right? So, babies are going to be garbage at this task. And that's because your brain is made of this physical matter, and it takes time to develop after many, 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 many iterations of practice of noticing the kinds of features that tend to go together within birds, and the features that distinguish those kinds of scenes versus vehicles or places or flowers. So let's contrast that with a situation where I don't have the right kind of existing network. Let's put me in a novel situation where I'm looking at new information and new data and see how well I do. Give me that same little stream of pictures, but now make them these unfamiliar shapes. Relatively simple in an information theoretic sense, right? We have just little rotated T's and L's or little green-red versus red-green patches. And now give me a little stream at the middle and make it really fast. And now give me a second task, a second array to do this with, and I'm terrible because I don't have pre-existing little networks in my head. They're going to help me do that task. By the way, this is a really cool classic study. If you look in the lower left, you'll see the first author's name is Lee. Many of you will know the AI researcher, Fei-Fei Li. This is actually started out in visual neuroscience. This is one of her first publications from a while back. Let me give you a sense of just how hard life is when you don't have these pre-existing networks. I'm going to give you a sample of what it's like to try to recognize just this object versus that object. And I'll make it a little more colorblind friendly. So I'll take away the red-green and I'll make it red-blue instead. And I'm going to ask you, please tell me where you see a red-blue among blue-reds in the following display. And I think you feel that it's surprisingly hard. You don't have a little picture in your head, a little template of what this configuration looks like. And I'll just give you the answers. It's this one and this one. Let me give you one more. Here's another display in case you want to try it again. It's the reverse this time. And it's this one and this one. And because you don't have that little template in your head, you don't have experience with this particular set of objects, it's going to be really tough. And that's why you're slow at this task. By the way, you can change your brain if you stare at these displays for a week straight and do many hours of practice. You can build up these little templates in your visual system that allow you to efficiently recognize the difference between these two objects in these displays. It does take many, many hours though to do it. Okay, so you are really bad with new, arbitrary, novel information. You're really good when you can recognize something that you have a lot of practice with. This gets particularly troublesome when information changes. What if we give you novel information, but then we change it, or then we move the display? In this kind of a situation, you can have a lot of trouble with not only representing information, but also tracking how it changes over time. I'll give you one of my favorite examples. This one's going to be really simple. Just check out these ice creams. Just watch this display. Wonder what's going on. That yellow one, is that like lemon or is that mustard flavor? Or what's happening? Many of you have not noticed that I'm doing something funny with this display right now. So as you watch it, just track the blue versus the green ice cream scoops. And you may not have noticed that they are constantly switching places. So because you don't have an existing template, an existing network for this particular configuration of colors, I can swap them and you don't actually realize that they're changing. So when you're in a novel situation, new information, and you don't have a pre-existing network in your brain, you're incredibly limited in what you can do. So be thankful that your brain has these existing networks, but what your brain is doing constantly is that these networks are constantly taking in new information, and the one that's most consistent with whatever new information comes in is battling it out with other potential networks that are representing other potential states of the world. The way that your brain works is that the one that is most consistent with the evidence, the one that's most activated, wins out and tends to overwrite the others to the degree that it can actually change what you're seeing so that you see more your past experience than what is currently in front of you. And there are lots of examples from this in cognitive science. So you've probably all seen this phenomenon where you're just unable to see the raw image here. What you see is you've got a face network in your head that loves to find faces and things. And in these cases, it's telling you that these are faces, and it's really hard to back away from that percept and just see the raw data. And this is the totalitarian aspect of what your brain does. A totalitarian government is one that has a certain ideology, a certain truth, and it doesn't let you have your own set of facts. It pushes a top-down story on the way that you see the world. And your brain has this proclivity to have these existing networks do the same whenever you're looking at new data and evidence. And it can also take what you're seeing in front of you and actually change it. It can also autocorrect what new information you're bringing in based on past experience. So when I say autocorrect, I mean the same thing that your phone does. If you are an English speaker and your phone is set to English mode, you'll be typing in Spanish to your friend who speaks Spanish. And because your phone is only used to the statistics of the English language and the way that the letters tend to form words in that language, it'll have this totalitarian autocorrect where it'll demand that you have misspelled the words muchas gracias and you must have said mucus gravitas because that's all it knows. So your brain does this kind of autocorrecting all the time. Here's an example from memory. This is a great paper where we have people look at a bunch of scenes. Not we, this is someone else's paper. This is Yamada et al. And they have people look at a bunch of scenes. And whenever you're looking at scenes, you have this signal in your head where you've seen kitchen scenes before, and you know that there's a typical set of features that tend to go in a kitchen scene, pots and spatulas and salt shakers. And so this totalitarian voice is telling you that there must be a salt shaker in that scene. And when you ask people what was in that picture before when you saw it, they will artificially remember. They will autocorrect to believe that there must have been a salt shaker there because according to your previous experience and the statistics, that was something that tended to be true in the past. So the evidence that you're getting in actually gets warped according to the statistics of what you've seen before. Now, I'm not saying that this is necessarily a bug in the brain. you should be glad that you have these networks, right? You need these networks. You cannot fly a plane or understand a molecule or become a physicist or even walk or talk or move or do anything else without these kinds of networks. They're critical to being able to pick out regularities in the world and recognize them later and take action in the world. In fact, that chess master, their memory, because they have this system, their memory can be amazing for the positions of chessboards. If you show them a chessboard, they can memorize it really quickly. And they can also memorize a dozen other chessboards. A chess expert can play 10 simultaneous games of blindfolded chess, walking from each board to the next, merely hearing their opponent verbally tell them the moves, because they have such a rich representational space of the possibilities of how chessboards can be laid out. And that memory can be completely dispelled if you show them a random chessboard that doesn't fit those statistics and those regularities. Their memory for the pieces on this randomly organized board is going to be terrible. They're going to be as bad as I would be at memorizing these positions. I also just want to insert a quick caveat here that while I'm talking about the dangers of these networks based on past statistics and experience, I'm not going to say that you have no flexibility and you can't represent new things. That chessboard in the upper right, yeah, I could memorize a little bit of it. I can maybe remember the positions of 4 to 5 pieces. Yeah, I can tell the difference between that blue and red organization, but it's incredibly limited. Without that beastly machine of that network that's representing all that past experience in parallel, it's really hard for me to have original thoughts at more than a few per second. And those thoughts are constantly fighting against the autocorrect of that long-term experience. This analogy of the totalitarian brain is actually from a great paper back in 1980 called The Totalitarian Ego, where Greenwald, the author, links this phenomenon in single human brains to the same phenomenon in small groups of people, to the same phenomenon in, let's say, the scientific community, where a certain idea about how something works tends to become dominant and it's hard to dispel it, all the way up to, of course, totalitarian governments. And in that paper, they use the analogy to the book 1984 by George Orwell. I'm using the slightly updated case of the Hungry Games, where we have the president here who runs a somewhat totalitarian government. If you're interested in this paper, you can read it, or you can find out about it the way I found out about it, through a great episode of the philosophy and psychology podcast, Very Bad Wizards. Just go to episode 83 and you'll hear a funny discussion of this paper, but informative, a great discussion. The totalitarian brain also filters what you see. It's not only what you take in and what sticks and the way you interpret it, but it's literally what information comes into your brain gets filtered by your past experience. By the way, the section that I'm about to start, I just want to note that there's a great sort of related work section in the second half of the paper from Han and Schulz. That's the talk, a talk and a half from now, where they talk about the relationship of exactly these filtering issues that I'm about to talk about to the difficulties that they can cause in visual analytics display. So the way that these networks work is that there's different networks in your brain that are representing different possible states of the world: duck, rabbit, Yanny, Laurel, gold, blue dress, etc. And they're fighting. And the way that they work, there's a classic paper in this, that Desimone and Duncan paper, is that these networks are constantly bickering and one of them wins. And the winner takes all. It suppresses the other network. So when one of these networks collects more evidence that the state of the world is duck versus bunny, it suppresses the other network so that you only see that one thing. It's black or white. There's no gray here. There's no nuance. By the way, if you'd like to see a more discussion of how these competitive interactions and forcing you to categorize the world into A or B affects your ability to just read basic marks in visualizations, check out these 2 talks. The easy way to find them is to go to the VIS program website and search the author for McColeman. So when you have a visual illusion like this, face versus vase, there's 2 possible states of the world, and there's a fight going on in your head right now. Your totalitarian brain comes in and has a mixing board where it says, my hypothesis is this is a face. And because it's a face, I'm going to amp up the features that go along with faces in this image, like the dark color. And so you're actually just going to see the face, and your brain will cause you to actively inhibit the rest of the image so that the evidence for the vase actually disappears in your brain. those of you that know this movie, if you're not familiar with this, walk away from your computer for 40 seconds and come back. Someone on Discord will give you the link on the bottom because you should experience it for yourself. Okay, for those of you that have seen this, there's a basketball game that you're watching. You're paying attention to the players in white, but not the players in black. And as you're doing that, you're turning up the filter for the signal of the white shirt. So you're inhibiting dark colors in the display. And what you don't notice until later is that there was actually a gorilla that walked through this basketball game. Here's an updated version of that, by the way. This is a great sort of replication and extension of that same result, where we have radiologists looking at x-rays of lungs. And you can see there's a gorilla up there in the lung. I just need to note that this paper also has one of my favorite independent variables of any paper, and it is gorilla opacity. And what you get is that even these radiologists who are experts are going to miss the gorilla in this image. And that's because they are so focused, they are so filtered on finding nodules in this lung image that they miss this little gorilla. Don't worry, they do still find potentially hazardous nodules in the image better than your average novice. Also, great news. Not only do you have these limits, but people are terrible at recognizing these limits. There's a phenomenon called change blindness. So you don't realize that you're going to miss changes. Dan Simons and Dan Levin have done a lot of this work. So on the left side, if you ask people, would you miss the gorilla? They'll say, are you kidding me? I wouldn't miss the gorilla. On the right side, there's another experiment that they've done where there's a real person swap. So you're talking to a construction worker, they're asking you directions, a door comes between you and the construction worker, and they get replaced by another person. Yes, people, would you notice that? And they say, of course. Here's the actual statistics. Would you notice? 70% say, yeah. Are you confident about that? Absolutely. Do they notice? No, right? So 0% of people notice that humongous change. So this is change blindness. By the way, the construction worker on the left, Dan Simons, was my PhD advisor. I was very lucky to be in his lab as a grad student. Brilliant fellow, also has a really fantastic, quirky and punny sense of humor. So given change blindness, he was trying to write another paper where he could have the title change blindness. So he tried to show the same phenomenon, but in displays like this of pocket change. And I believe he actually ran the experiment at some point. I do remember around 2002, a lab meeting that got way out of hand where he had come up with a way to have a recursive paper title like this. My working memory is not strong enough to figure out what that would have been, but I do recall that he had worked it out. Okay, here's another example of this metacognitive error of not predicting that your brain gets stuck in these little states. This is some work from Cindy Xiong and Lisan van Wielden. And this is on the cursive expertise. Cindy tells you this interesting story about some data. Look, there's some politicians and there's their polling data, and you can see they had a debate and one of the politicians did badly and you can see the scores come together. And then the politician did well later on and the scores went up. It's a juicy story. And now I'd like you to predict what somebody else will see in this graph. Now that you've gotten locked into those top two lines. By the way, this person, we're going to grab them from out in the hall. They don't know the story. They don't know the background. What are they going to see as being most salient in this graph? And one person writes this and one person writes this. Overall, people will predict that others will see the same patterns as salient that they see because they get locked into this one view of the data. Then you run the second condition where, I mean, maybe they're right. Maybe the top two lines are just more interesting. They're on the top, right? So you tell exactly the same story about these two lines on the bottom, and then you get data that look instead like this. So it's not just that the top two are important, it's really that people get locked into a certain view of their data. There's other demonstrations of this. I think if you pop to this website on the bottom, you'll see great examples of how when you look at this image, you think that you're seeing all of these changes in this novel display of information, but you're not. Keep your eyes on the center. What you're really seeing is just the luminance flicker. And we can show you that because when we move the display, the luminance flicker signal gets swamped. And now you can no longer see those changes because your brain is just using this little statistic of the luminance flicker to convince you that you're seeing the changes. By the way, if you go check out these demos, they do the same experiment, but with all of the encoding channels that are typically used in data visualization. So luminance, size, and shape. And you can see that in all these cases, without having the flicker of the actual change there, you don't notice that these things are changing. Okay. All right, so what can we do about all this? How can visualization designers and automated systems help get us out of this totalitarian brain oppression? Well, you can help by pushing people to see new views in data. People can get locked into a given view once they've looked at something. I love this New York Times interactive where they show that a Democrat looking at these unemployment rates under Obama, this is Obama's party, the Democrats, would probably annotate and say, look at how these job numbers, this unemployment rate is dropping. Go Obama. But a conservative, somebody, a member of the other party, would probably note that Obama promised 8% unemployment. And look at all that area under the curve. Every pixel is 5,000 people without a job that can't feed their family and put food on the table. Obama. So there's different ways that you can push people into seeing one view of the data or another. And data journalists in particular will use these techniques to try to show you what the data looks to them so that they help you see the right view of the data. And there's a lot of trust involved in that. And so they'll disambiguate otherwise ambiguous visualizations to show you the pattern that you should pay attention to. So there's lots of examples. We have this annotation and coloring. We have Hans Rosling, who's going to walk you through data visualization and point out what you should be paying attention to. Even if he's not using annotation and highlighting, he's helping you see what he sees. So these techniques can get used in visual analytics systems. I love this paper from last year where we have the increased salience of otherwise ignored points. We have explicit displays of how along this dimension, hey user, you tend to be looking at these aspects of the data, but the distribution's actually here. Maybe you should be looking more to the right a little bit. There's also strategies like consider the opposite. So I know you're thinking about this, but let's also maybe think about this. And more complex versions of that, like analysis of competing hypotheses. So I want to thank all the folks that do all the work and the wonderful people that are around in the lab and the folks that pay for all the things. And I'll just end with a quick summary. Can you trust your own brain when you're doing analytics? Watch out for this totalitarian aspect of how your brain uses past experience to fill in all these holes and missing information. You have these powerful existing networks, and you should be glad that you have them because they allow you to do experty things in the world. But as soon as you get into a novel situation, you're trying to see things through a new lens, it's tough. And these existing networks will cause you to filter and autocorrect information in the world. And you're bad at recognizing that this happens. So hopefully folks that are designing analytic systems and communicating data are thinking of ways that we can design systems to help people break out of these problematic habits. Thanks. I'll leave. I think we probably won't have time for questions, but these are contact methods below. Thanks very much.
Thank you very much, Steve. It was a great way to kick off TREX. It was an interesting talk, and I think we got the audience engaged, so yay. We don't have so much time for the Q&A, but I'm going to ask one question at least. So someone, I think Georgetta Elisabetta Mari asked, so wait, if your brain can switch between the two interpretations, does that mean you don't have a totalitarian brain, but a disassociated brain? What's the science or scientific term there?
So the scientific term is going to be that it's going to be biased competition. So you have these networks and they fight with each other. And the reason why the word biased is in there is not the bias that we're thinking of in the context of this workshop. It's the fact that you can help one of the networks beat the other. So the point I want to make is that these networks do tend to operate in a winner-take-all fashion. So you see either the duck or the rabbit. You look at these candidates or these candidates. But your brain can break out of that dominance of one percept over the other. But the way that you do it is you tend to move your eyes to a different part of the screen, or you tend to pay attention to the red dots, or you tend to pay attention to the ones that are moving upward. And that's a place where annotation really helps, where you say, look here, color these things in, point to things, and you can help that network that's currently getting squashed take over and be dominant. So in the end, you're only getting dominance of one of these networks at a time, but you can push them around and help out the little one so that it can defeat the one that's currently winning.
Great. And another question, it was the first question, so I'm going to ask it. Steve Gomez asked, was mentioning the mustard ice cream intended to distract us from noticing the green-blue switches?
A little bit, but it works either way. You can go back and show the video to other people and turn off the sound and it'll still work. I use that demo all the time. It was a little sneaky tactic just to make sure that it worked today. But yeah, it should work anyway.
Great. Thank you so much, Steve. Steve will be one of the panelists at the end of the session. So if you have more questions, we encourage you to be there. Also, Steve, if there are more questions in the Discord, can you please go and engage with the people? That would be great.
I'll be on. Thanks.
Thank you so much, Steve, for your talk. So we will move to the first paper presentation if our technician will help us. Thank you. Okay, so our first paper presentation, which is also a full paper, is going to be presented by Dustin Arendt. He's from Pacific North Laboratory, and he's going to have his talk on measure utility, gain trust, practical advice for XAI researchers. Note that the extended version of the video is also available on TREX schedule page. So please check it out if you want an extended version. Thank you.
Hi, my name is Dustin Arendt, and I'm from Pacific Northwest National Laboratory. So I'm going to be talking very briefly about our position paper at TREX titled Measure Utility Gain Trust, Practical Advice for XAI Researchers. And before I really get into the contents of the paper, I wanted to talk a little bit about why we're talking about explanations at a visualization workshop. And I think, well, for me and other people, it might be obvious, but I think it's worth really stating that I and others kind of have the opinion that most explanations actually are visualizations. And so it's a very appropriate topic for this venue. There are a few examples where explanations are text or things like that, and are not really visualizations, but really explanations convey highly complex concepts. And the best tools that we have in our quiver, or the best arrows in our quiver that we have to do that are visualizations. And so that's why I think it's a good fit. And another thing that makes us highly relevant is that all of the techniques that we have to evaluate visualizations, we should be able to apply to explanations. So I want to encourage our community to share the techniques that we have more broadly. So we can evaluate it. We have the technology, we have the capability to do this. Okay, so that's why I'm talking about machine learning explanations. But really the thing that I want to get into more is our position on this paper. And so our position is essentially that we should be evaluating explanations primarily through a utility-based evaluation rather than focusing on trust. So sometimes the purpose of an explanation is to increase or calibrate trust, but that's actually a pretty narrow view of what explanations do. And if we really want to have a way of understanding the goodness of an explanation, we could focus more on utility, which lets us be more inclusive and more broadly encompassing of what explanations actually do. There are also some dangers in essentially just focusing on trust, especially on the design side of explanations. So if you're building an explanation and you're designing to maximize the trustworthiness of the explanation, you can actually get into some dangerous territory there with creating conditions of overtrust. Okay, so when do we think trust is appropriate to measure for an explanation? Well, we think that happens, or that's appropriate in a more longitudinal type study. So a situation where you have something that's actually implemented, that's being used in the wild, and you want to understand how people's trust in that changes over a long period of time, because trust in people takes a long time to develop. So this is probably not an appropriate measurement to do for a 30-minute user study at a university for a person that's never seen this thing before. So instead, we really should focus on more objective measurements of utility rather than trust. And when we do focus on utility, we have the advantage of being able to focus explicitly on like the purpose of that explanation, which is more broad than just explanation itself. It usually fits into a broader workflow. So going a little bit deeper, what does the sort of gold standard for an explainable AI evaluation look like? So we suggest in the paper that you should consider these 4 groups. The one on the bottom is obviously the most important. So what we want is to have some sort of group of participants in the study where a person and a machine learning algorithm and an explanation all work together in some kind of system, and we can measure the performance of that. And then the second most important thing is that we can take that explanation away. And so whatever task that first group was doing, we should be able to have the second group do without the explanation. And if that's not possible, then you may want to reconsider your study because you don't have a very good way of attributing any performance gains to the explanation itself. The other groups where the human only and the machine only perform the task, those are kind of optional and they can provide context, but may not be practical in all situations. So given that I only have a few moments left in this sort of preview of our paper, I want to walk through the practical side of what we talk about in the paper. So in the paper, we talk about 5 different use cases or application domains of explanations, and we work through some what we call pseudo experiments, where we outline how you could actually evaluate an explanation in these domains. And so the first one is pretty interesting, and it actually is inspired by work that we recently submitted and is under peer review, so I won't go into too much detail. But the idea is that we could actually ask a user to do a really interesting task, which is to, given a machine learning classification, so let's say the machine learning algorithm makes a prediction about what it sees in an image, can the user actually tell us why the algorithm made a mistake when it does make a mistake? And with a carefully curated ground truth data set, we can actually measure users' performance of this task. And we can do this with and without the explanation. And so this helps us understand the effectiveness of the explanation in a model debugging domain. We could do something similar for a model selection use case where we give the user 2 models and ask the user which model is better, but we really only give a few examples and explanations of the examples. And so the user can make a judgment call about which model is actually better just based solely on the explanation or based on the misclassifications without the explanation. And I know I'm running out of time, so the only other experiment that I'll talk about is this one in terms of mental model and model understanding. So this one is really interesting too. Here, what we can do is actually give the user a couple of, well, we can give the user 1 model and ask the user to predict what the behavior of the model will be. So how good the user is at predicting what the model predicts is a measurement of how much they understand the model. And of course, they can do this with and without the explanation. And then there are a couple other variations of this we talk about in the paper. But with that, I'm just going to wrap it up and say thanks for this opportunity to preview our paper. I hope you read it. Also, please look at the longer video where we go through this in much more detail. And I'd just like to thank my co-authors on this paper, Brittany Davis, Maria Glenski, Will Seeley, and Will Seeley. And with that, I'll wrap it up. Here's the contact information for the corresponding authors. And thanks.
Thank you, Dustin. This was an amazing paper. Thank you so much. There is a few questions that we can ask you. Emily actually said that she loved the idea of evaluation with human only, machine only, human plus machine, and human machine explanation. It seems like the first two are usually not included. Human only and machine only. Are you aware of specific papers that you can point into the Discord chat that might be useful for us to look at or just mention here?
Yeah, I can point you selfishly towards one of my own papers that was published in ACM IUI 2020, and I'm blanking on the exact title, but it's essentially around fostering appropriate trust. And that was an experiment where we gave users pictures of leaves, and so they couldn't actually, so the task was a classification task, show a picture of a leaf to a person and ask them what type of tree it's from, and people generally don't know how to do this. And we were actually able to measure the human only and the machine only performance. We decided not to measure the human only performance because we assumed that that it was basically just random. But we could have done that. What we did was we measured the machine only and then the human and human machine explanation. And basically in the human plus machine case, the performance was identical to the machine only case there because they were just following what the machine was saying.
Great. So Dustin will be at the end for the discussion, actually at the end of the second session. So I think we will continue this discussion after, but thank you very much for being here today and your awesome presentation. So I think Emily will introduce the next paper.
Yeah, so it's my pleasure to introduce our next speaker. Wenkai Han will be presenting their paper on behalf of him and his colleague Hans-Jörg Schulz on the topic Beyond Trust Building, Calibrating Trust in Visual Analytics. So yeah, Wenkai, please take it away.
Hi everyone, I'm Wenkai Han from Aarhus University in Denmark, and I'm very excited to present our paper on trust in VA today. To talk about trust in VA, we need to go back to the origin of VA, where it was intended to bring the unique but different abilities of human and computer together. Computers are good at indexing and searching a large amount of data as well as computation, while human can use their knowledge and creativity to generate insights and solve problems. VA depends on this close cooperation between human and machine, and when we talk about such cooperation, the concept of trust becomes increasingly important. So first, let's define what is trust in VA. Combining the definition of trust and the goal of VA, we define the trust in VA as the user's belief that the VA system will help them correctly identify and visually distill the most valuable and relevant information content. Many previous work have talked about trust in a dichotomous way of trust and distrust, focusing mostly on building users' trust and, of course, avoiding distrust. However, there are a couple of issues with such approach. First, we often do not and should not easily fall into the extreme side of trust or distrust, but usually retain some degree of healthy skepticism. So it is therefore important to identify such intermediate states such as untrust, where the user is not yet fully confident in the VA system, and also on distrust, where the user becomes suspicious of the VIS system, but have not fully distrusted it. Another perspective missing here is how trust and trustworthiness are two related but different concepts. Trust, as we discussed before, is a belief that the user might have on the VIS system. However, user might trust a system that is actually not trustworthy. This is also problematic as users might misuse the system because of such mistrust. This might cause even more trust issues when they later realize such trust was not justified. On the other side of the spectrum, misdistrust denotes situation where users put distrust in systems that are actually trustworthy. So in this paper, we emphasize that in addition to trust building, trust calibration is equally important as it helps to avoid unmet expectation from users, misuse of the VIS system, and later regrets that such misuse might cause. Here we give a brief overview of potential trust calibration issues in VA, and more details and examples can be found in the paper. On the side of VIS system, data are first collected through many social and technical constraints and are never raw. For example, just the decision of what to collect and what not to collect can severely skew the data set. And this often partial data fit into potentially biased algorithms that work like a black box. They create unreliable results without provenance. Visual mapping of these unreliable computation results can be further skewed due to inevitable overplotting and loss of details that come with the hardware limitations and a large amount of data. On the top of it, interaction designer of a system often come with a specific conceptual model regarding logic, space, and time, which usually do not fully match with users' mental model, and such mismatch will lead to misuse. Now we have only talked about the trust issues on VIS system. Trust issues on the user side can also make users themselves not trustworthy and have important influences on trust calibration. First, a user's perceptual abilities, disabilities, and errors such as color and change blindness might hinder them from accurately perceiving information. And such inaccurate perception subsequently fit into users' knowledge construct that might not be fully competent to understand the information and accurately evaluate the trustworthiness of the VIS system. Users also have different cognitive biases, such as confirmation bias and personal factors like the culture of uncertainty avoidance that can lead to often irrational judgment. On the top of such situational factors like mood and physical environment will also lead to unstable decision-making. These issues in users can severely skew their evaluation of both the system, both the information and the trustworthiness of the VIS system, and therefore bring challenges to trust calibration. In this paper, we make a clear distinction between trust building and trust calibration and bring attention to the trust calibration for matching users' perceived trust and the actual trustworthiness of the VIS system. However, much more research needs to be done to gain a more comprehensive understanding of trust calibration in VA. To begin with, trust building and calibration can stand in conflict with each other. When the actual trustworthiness of a VIS system is low, building perceived trust would actively miscalibrate it. Therefore, it is important to consider and investigate how trust building and calibration should coexist. Furthermore, tracking trust calibration can be a dynamic process that requires continuous monitoring of trust and trustworthiness. How to evaluate trust calibration is therefore an important but complicated question to address. Potential ways can be through a survey or as well as tracking user action and physical measurement. But is there any new way to do this? For example, maybe provide some questionable information from time to time to detect if users are still alert and aware of the potential issues in the VIS system. In addition, with so many factors involved in the trust dynamics and different emerging VA approaches, both theoretical and empirical research is needed to fully dissect and investigate the trust dynamics in VA. With that, we hope this paper provoked new discussions and consideration on trust issues in VA, and thank you for your attention.
Yeah, thank you for the talk, Wenkai. So I just saw a question come in on the Discord channel. So from Fumeng Yang at Brown. So except for distrust, untrust, and trust, should there be a zone of overtrust where people trust a system or visualization when they should not? Do you have any insights that you can share about overtrust?
So I think the term overtrust is also kind of already used in this area, but we kind of try to dissect a bit more in our paper, especially to have this, I think, what was that again? Yeah, distrust and untrust, and then also with the on distrust and such, so that it can go into the paper and see that we kind of make some niche differences between undertrust, overtrust, and those concepts. Yeah.
Great, thank you. So I think to stay on track, we should move on to the next next invited speaker. I do just want to quickly mention that we've added an additional channel on the Discord chat for the discussion panel. So if anyone has higher level questions that you would like to pose to feed the ongoing discussion, then please post it to that Discord channel.
Yep.
Thank you, Wenkai. Okay, yeah, it's my pleasure to introduce our next invited speaker, BC Kwon. So I collaborated with BC several years ago on a project, and I'm proud that I could use that little bit of leverage years later to twist his arm into talking with us today about transparency and trust in healthcare. So BC has a number of roles. He's a research scientist at IBM, lecturer at Columbia University, and he's a visiting scientist at Broad Institute of MIT and Harvard as well. BC's research spans across topics including visual analytics, machine learning, and healthcare. And I also want to point out that he has a paper later on this week on visual analytics with hidden Markov models for disease progression pathways. So keep an eye out for that. Yeah, now please join me in giving a virtual welcome to BC for his talk titled Towards Visual Analytics for AI Transparency and Trust in Healthcare.
So hello everyone, and thank you very much, Emily, for introducing me. So I'm going to talk about Towards Visual Analytics for AI Transparency and Trust in Healthcare. So AI in healthcare is rising, and as you can see, its market is projected to increase from $4.9 billion to $31 billion by 2025, according to reports. And we also see exponential growth in the number of AI-related publications on healthcare, which is consistent with the well-documented research trend in artificial intelligence as well. There are lots of wide range of application areas of AI in healthcare and medicine. Some of the examples are risk predictions or disease progression modeling, or decision support systems, drug discovery, to name a few. Despite such growing trends, the adoption of AI remains very slow and limited. There are many hurdles, just like skills of staff, it's not ready, and understanding of the benefits and uses, and also we lack of open source data, so which may be pose some hurdles for this adoption. And many government agencies report that AI research needs to focus more on explainability and transparency to earn trust. So there is a reluctance of adoption from healthcare provider sides. So according to KPMG reports, which is published in 2020, 91% of healthcare decision makers believe AI will increase access to care. However, 75% of healthcare decision makers believe that it could threaten the security and privacy of patient data. So there's a mixed feeling about this AI in general. There's also some strong resistance from patient side about this AI-enabled healthcare. So in some experiments, patients show a strong resistance to AI, reporting that they prefer having human care providers, even if it means a higher risk of inaccurate diagnosis or surgical complications. The main reason of this disbelief is that they don't think AI does take into account for their uniqueness. So that's why they're more comfortable using medical AI if physicians take full charge of the final decisions. So by working on this multidisciplinary healthcare research team at IBM throughout multiple years, I think the earning trust in AI could be a visualization problem. To earn trust AI, I think we need to achieve the following things according to the paper, Shea et al. So we need to achieve the explainability. So we need to have a transparency and understanding and how the reliability of the model. We also need to have ability to inspect bias, fairness, and robustness and compliance. Also, we want to evaluate privacy and quality of patient data. Also want to make sure the alignment of those AI-enabled systems with existing clinical workflows. And every step of the process, we need various different kinds of healthcare stakeholders involved. So that's why I think human in the loop with visualization could be a solution. So I'd like to navigate this problem space together, and then I want to introduce life cycles of AI in healthcare briefly, and also various stakeholders or personas involved in this process. Let's first dive into stakeholders. I think one of the unique characteristics in healthcare is that we have various stakeholders. For example, we have data scientists, statisticians, bioinformaticians, or healthcare data analysts. We also have clinical researchers. We have clinicians at the point of care, and then the recipients of them, patients, also caretakers, friends and family. And we also have policymakers and regulators. You can see all these diverse stakeholders. They have varying goals and varying expertise levels in healthcare and AI. So life cycles of AI in healthcare. So I just roughly draw this diagram to explain the life cycle of AI. So we initially start collecting data. It could be on observational data collected from clinical studies, clinical trials, or it could be just collected from electronic health records whenever patients visit clinics, or it could be some patient-generated data. So once we collect data, depending on our goals, we need to prepare our data to use it for AI. And then we build model. And then once we build a model, we make it for decisions or analysis. So we had this 5 different groups of stakeholders. I think what we need to do is we need to improve transparency through the life cycles just beyond AI explainability. Let's take a look at one by one how each stakeholder is involved in this process. So data scientists, they are doing building the models. So they do feature engineering, they train the model, they do the experiments to validate the model, the fitness, and they also test the model with some unseen data. Recently, I've seen a wide range of successful applications of visual analytics in this domain. To name a few, LSTM VIS or CNN VIS or SAN VIS. These are applications that help data scientists to inspect and debug models using interactive visualizations. Let's move on to clinical researchers. So clinical researchers, they aim to advance the field of medicine by conducting their research. So their goal is to test their hypothesis and to acquire knowledge about certain disease or certain patients, and etc. So in this process, AI itself is a great tool they can use to find the patterns in their data. So they are involved in all of these life cycles, starting with the data collection. So they sometimes conduct clinical trials, and they also retrieve EHLs. And then they also need to prepare their data by doing data harmonizations or standardizing measurements. And finally, they also need to construct a cohort based on their hypothesis. And then they are also involved in choosing a right model for their hypothesis, and then build a model, validate the model, and they also need to interpret the model. With the model in hand, they finally start exploring the data with the model inferences or model outcomes. And then by doing so, they gain insights and also communicate insights to discuss with their colleagues. When they're doing it, they also need to understand what are the limitations of the model as well. There are some growing interest in this direction where you use explainability methods plus visualizations. For example, SHAP is a research publication published in NeurIPS a couple of years ago, and they also have an open source library in which you have a variety of different options to visualize the explainable methods. Recently, we also worked on a CEM Explorer, which is combining contrastive explanation methods and PRODASH methods, which are examples of AI explainability methods with some interactive visualizations. Also for exploration and gaining insights. So these are some of the examples I worked on with many colleagues. So these examples allow users to interpret the models and model outcomes and explore the outcomes visually and gain insights and then to understand what's going on with their patients and what are the processes of this disease progression patterns. They also sometimes conduct what-if analysis by changing the inputs and then by taking a look at how outputs changes according to the input changes. They also provide feedback to the model to retrain the models or reconstruct the models as well. I think there are growing interest in this area of research, and there are a lot of open research questions in this direction. I think that's because we have multidisciplinary team of clinical experts and data scientists need to be involved. Clinical experts know best about how their data are collected, and they also understand better about how they need to standardize some of the medical measurements. And data scientists understand the model building process better, and we need to glue them together so that they can work together to advance the field of medicine by testing their hypothesis. So how can we support this multidisciplinary research? How can we let them understand the model better, interpret the results for clinical insights, and how can they communicate their scientific results to some manuscripts? The other life cycles stakeholders are clinicians and patients. So their goal is to understand the patient status, and they want to also make decisions for patient care. And when they do that, they also want to understand the limits of the model. So here, the question is, so we need to facilitate and help communication at this point of care. The model will provide some insights to the physicians. However, physicians also need to gain actionable insights. So what are the next best steps they need to do? And also they need to understand the validity and limits of the model, how the model is being trained. So it is okay to use in particular use cases. So they have to know that. So in a sense, they need to put appropriate trust in the model. So they need to know when or when not they can use the model. Also, patients want to understand how the AI is making decisions. To gain trust for the patients, we also need to communicate AI decisions, likelihood and risks. So there are some growing examples in the field of medicine. So these are examples of so-called model fact labels or AI fact sheets, so that physicians can take a look at these fact labels, just like food labels, like a nutrient facts. They can understand how the model was trained, what are the limitations, and so on. There's also a growing interest in how to facilitate communication between physicians and patients. So in a study from DePros et al., they found that understanding and explainability and trust are associated with each other. And we need to educate physicians and patients about AI in order to gain trust in it for better healthcare. Recently, there was another paper in Kai 2020 by Kwon and Karahalios, studies about how to facilitate patient-clinician communication through behavioral visualizations. I think we need more work on this direction too. More recently, a lot of people, like patients, are actually searching for the information on the web by themselves, and they want to learn more about the risks and treatments for many different diseases. So health data communication is one field that we also need to pay attention to. Patients, they're general public. We need to consider health literacy and numeracy and also visualization literacy. So in this educational purpose, we can also leverage the storytelling visualizations, and we also need to consider the platform because a lot more patients and users are working on mobile device, so we need to deliver visualization on mobile. And finally, policymakers and regulators. So their goal is to create, refine, evaluate AI guidance for healthcare. So they also want to make sure that the model is not biased. They also want to inspect the fairness, and robustness, and compliance. A couple of insightful articles. So the story from Chicago. So one of the best predictive variable for length of stays in hospital was actually the postal codes. And the postal codes was correlated with the longer hospital stays or in relatively poor and predominantly African American neighborhoods. And the poor areas were because they were admitted with more severe conditions, or perhaps they were less likely to be prescribed the drugs they needed. So those kinds of biases are actually introduced into the data, and they also further fed into the model, which can make the model unfair and biased. So there are a couple of examples like VIS and discrete lens. We need more interactive applications to really take a look at this cycle. So to summarize, multiple stakeholders having varying goals and expertise levels, we need visualizations for the steps in this pipeline. I'm going to give a quick case study and how I conducted my research, which will be presented this Friday. So it's a design study with clinical, statistical, and visualization experts. So our team is called Tie-Dye Study Group, which involves 50 plus scientists who are clinicians with expertise in type 1 diabetes and statistics and visualizations. We collaboratively conduct research to better understand the disease. So our goal was to find out heterogeneous disease progression patterns, which will lead us to better understanding of the etiology and eventually the treatment sequences. So first problem was the data preparations. So we had a large observational data collected from 5 different institutions. They span different European and North American countries. And they include observations collected in different manner. So we had to make sure that we harmonize their data because their recruitment criteria are different. Also, there are significant differences in measures. For example, all of them are using different thresholds for islet autoantibody positivity. So we need to make sure that they are standardized. We also need to construct the cohorts for our exploration. And then for the modeling choices, we also needed to explain how the model works because the clinicians are not experts in data modeling. So for a hidden Markov model, we draw the diagrams and make sure how this works, how we probabilistically find the states, and how the states are manifested by the clinical measures. We also explained it using some stick figures and how each patient's data could be explained by these model inferences. We introduce this using this step-by-step manner so that they can understand how the model works. And then we did some experiments, also trained the model. We also explained how the model constraints work and parameter choices will impact the modeling. So we drew diagrams. We also show the evaluation results using visualizations. And finally, the outcome was the visualization itself, the interactive dashboard called the VIS. And then we even used a diagram for our clinical abstracts and manuscripts. We got accepted to some premier venues in diabetes. So in this whole process, different kinds of visualizations were being used to communicate and make this whole process more transparent to all of the clinicians and model builders. What's exciting about it is while we're doing this multidisciplinary research, we actually get to present our work in a variety of different clinical conferences and visualization venues. It has been a long mutual learning process. I think as Hal et al. Explained, a design study like this is like a design by immersion. We mutually grow our understanding of other fields. And this process includes many trials and errors, but it's indeed a joyful way to learn about the fields. So I would like to conclude with calling for multidisciplinary healthcare research. The field is growing, but the stakeholders are reluctant to adopt them. So we need to earn trust, and stakeholders need to be involved in the life cycles. I think visualizations can be a viable solution. And we can increase transparency via visualizations to earn trust. So we need more collaborative projects towards visual analytics for AI transparency and trust in healthcare. So please talk to me if you're interested. And please consider submitting your work for visual analytics in healthcare workshop, which I am doing a co-chair this year. I'd like to thank my supporters, and thank you very much.
Yeah, thanks, BC, for the talk. I wanted to actually just skip to the discussion phase and the panel discussion, because I think the first question for you might actually be a good one for us to just pose to all of our panelists. So the question was from Steve, actually. So I love the nutrition label metaphor to explain models to patients. So I wonder what other already known metaphors are common in communicating machine learning and AI models to lay audiences in health and other domains. So maybe BC, you can kick that off if you have some thoughts about that, and others can jump in.
Yeah. Well, I personally don't know any other good metaphors. I think nutrient labels are something that people are discussing right now, but I don't know.
Yeah, maybe Steve, did you have other thoughts on that when you were asking the question?
Can you see me? I'm not showing up on the screen. You can hear me?
Yes. Yeah.
Okay, yeah, so I'm just asking the question because so I think it's a really cool system, and then you need the patient to understand how it works in order to trust it. And one way that people achieve these goals sometimes is to leverage like existing networks in your head, right? Like they know a lot about nutrition labels and they know how that works. And so you're leveraging an existing cluster of experience in people's brains, and that loads in 80 or 90% of what's important. And then you're giving it these little twists and saying, well, the ingredients are this. And I just thought it's really a clever way to introduce a new concept to people, leveraging something that's already in their head. So I do see that on the Discord server, there is a paper that was mentioned by, let me just get the person's name, by Jeremy Block. There's a paper that kind of summarizes other ways called model cards, other ways of using these sorts of metaphors to express these complicated systems to folks that have never heard of them before?
Yeah, I just came up with one, which is not related to AI in general, but so a lot of healthcare practitioners that I collaborate with are talking about how people increase or decrease their risks. So rise and fall. So they wanted to actually see that kind of effects in visualizations. So that was one reason why we came up with this waterfall visualization where actually patients follow the step. So if their conditions get worsened, so you actually go down to the next steps. So we just follow this kind of metaphor of rise and so increase and decrease in their risks in general.
Yeah, that's great. So actually the next question was sort of inspired by Steve's and Wenkai's talks. So the question is, a lot of trust calibration seems to rely on a benevolent other to make us aware of the presence of uncertainty or bias. So for all of our panelists, do you have thoughts on how to empower individuals to make these judgments themselves and perhaps not be so reliant on assuming that everyone has our best interests in mind and communicating that information to us?
Well, I guess I can start with, I think data literacy is one of the most important part to address this issue kind of by just education. But also, I guess when you design a system, there are ways kind of to, but this also kind of depends on the part of the designer, kind of the way of involving users in early stage so that they get the information, they understand the ideas and behind designing certain systems so that they develop the knowledge to use it over time. But I think the most important part is in some way to involve the users from an early stage so that they learn about it, or that we have to reach out as a community, as a VIS community, to reach out to the user in some way to educate and to improve the data literacy in general.
I think this is an excellent, really fun question because it's just so important that I think it's right on the money. A lot of things that we're doing falls into the realm of trying to call attention to these potential problems so people are aware of it. But what if there's data presenters who intentionally don't want us to understand these issues, these problems? Do we have deceptive presentations of data? And it's just, I think I agree that general education is a big part of it. Maybe if there's a way to encourage a healthy skepticism in cases where there's systems that don't have sufficient level of transparency at the start, then maybe we can try to encourage people to question this and be thinking in terms of these issues of data literacy from the get-go. But it's a very difficult problem.
I want to make a quick link to a literature that I know a little better, and that's the medical risk literature, where this comes up sometimes, where you just want a patient to make a simple decision about whether to get a certain treatment or take a certain drug. And there's just basic statistics about survival rates or cure rates, et cetera, that you're trying to convey to them. And the physicians often has this tension of just saying, like, just take this thing, like, trust me, it's fine, versus wanting the patient to make an informed decision. And even these really simple base rate, what's the denominator, et cetera, issues are hard to explain. And then there's this whole literature on using icon arrays and presenting things with metaphors, et cetera. But that tension is there where the physician is often just tempted to say, just trust me, I've got it. But the tension is that against an informed decision where the person fully understands where that recommendation is coming from.
Yeah, a lot of patients that I worked with, I think, have some troubles with basic, I guess, how the probabilities work and what the percentile is versus percents. And that's something that we need to consider while designing this health communication like visualization, for example. I personally believe there will be a way to use storytelling and use a good metaphor, as just Steve mentioned, could be a really helpful way for them to really associate themselves with this very scary numbers. So I think there's definitely research opportunities there.
Yeah, so it seems like a lot of it really boils down to, you know, an education problem, just increasing people's awareness and skepticism in an appropriate way. Yeah, so I think we're out of time and we should jump to the break. And I don't have a nice way to get to that, but there we go. I've like flashed through some other questions we had, but we can perhaps revisit those questions once we get to the second panel discussion. Mahsan, do you have any final?
I just wanted to thank all of the presenters for this session and every participant in the audience that asked questions and tried to engage with us. Please come back after the break. We are going to have another keynote and three cool presentations, and we will have a longer discussion panel. So we'll see you after the break. Thank you. Hi, everyone. For those of you who just joined us, welcome to TREX, the virtual workshop on trust and expertise in visualization systems. For those of who you are returning from the break, welcome. Back, of course. My name is Mahsan Nourani. I'm a fourth-year PhD student at University of Florida. And along with Emily Wall from Northwestern University, I'm chairing this workshop today. So before the break, we had the first session of our workshop with amazing discussions and conversations on the Discord and also YouTube chat. And so we are really appreciating all the audience who helped us, get that discussion going. And we also want to invite everyone else who just joined or comes back from the break to keep the discussion going, ask questions, be involved with the conversations, because we want this workshop to be not a one-sided thing, and we want everyone to be more involved. And probably based on what we did, we are going to have our discussions and panels at the end of the session also follow your questions and the discussion topics that you are interested in. So please make sure that you are involved. And also in this session, we will have another keynote speaker in the beginning, plus 3 presentations afterwards, and a longer panel discussion at the end. So please make sure to stay until the end. So I am very delighted and honored to welcome Jen Wortman-Kwon as our next invited speaker. She's a familiar and active face in the machine learning community, but it is her first time at IEEE VIS, and we are so excited to have her here with us. Jen is a senior principal researcher in Microsoft Research in the FATE team, where she studies and works with algorithmic transparency and fairness in AI, mainly from a human-centered perspective. Other than her impactful research and community service, she has been advocating and providing support for women in CS, for which she has co-founded the annual workshop for women in machine learning. So we are, welcome, Jen. We are excited to have you here. Today, Jen will be presenting her work at a talk on intelligibility throughout the machine learning lifecycle. Thank you very much, and we all are all ears.
Okay, hi. Thank you so much for inviting me, and I'm so excited to be here today. As Mahsan said, I'm Jen Wortman-Kwon. I'm a senior principal researcher here at Microsoft Research in New York City, where I'm part of the FATE group at MSR. I'm talking to you today from my home in Brooklyn. I want to just be upfront that I'm not a visualization researcher, although this is a community that I would love to interact with more. I was actually supposed to attend VIS for the first time in Vancouver last year to speak at another workshop, but I had to cancel my trip last minute because I got too sick to travel, and I was really disappointed to miss out. So I'm so excited to be here this year and have this second chance. In this talk, I'm going to be arguing for the importance of taking a human-centered approach to intelligibility, which I would argue means that there needs to be more collaboration in this space between the machine learning community, the HCI community, and the VIS community as well. And I will come back to this at the end of my talk. Okay, so first of all, why should we take a human-centered approach to intelligibility? Well, we often think about machine learning and actually teach machine learning as if it's this fully automated process, right? We take some data, we use it to learn a model, and out come our automated predictions. But one thing I've learned over the years is that people are at the heart of the machine learning lifecycle. People define the problems that machine learning is going to be used to solve. People decide which data to collect. They decide how to clean and process that data and how to label it. And the data itself is often generated by people, either explicitly, for example, through crowdsourcing, or implicitly. For example, if the data contains images of people or text that people have written. People determine what model to use, should use a neural network, a random forest, a linear model. They choose how to train the model. They choose how to test the model, which may require gathering more data from additional people. People make choices about whether, where, and how to deploy the model. And of course, deployed models end up impacting other people's lives, sometimes in high stakes domains like medicine or finance. And finally, feedback from these people is incorporated as the model evolves. Given this really central role that people play in the machine learning lifecycle, I take the position in my work that building machine learning systems that are reliable, trustworthy, and fair requires that relevant stakeholders have at least a basic understanding of how they work. So to give you a bit more background on the landscape of what I'm talking about here, the approaches to model intelligibility coming out of the machine learning community generally fall in two categories. So the first type of approach is to design and deploy transparent or glass box models that are intuitively simple. So simple might mean something like a small decision tree or sparse linear model. So as one example, my colleague Dan Goldstein and some collaborators of his have a really nice piece of work on simple point systems that a decision maker, so for example, a judge, could memorize and apply on the fly without even needing a pencil and paper. They show that in high stakes domains, at least when you have tabular data, these point systems are nearly as accurate as more complex models like neural networks. As another example, my colleague Rich Caruana has a body of work on generalized additive models, or GAMs, that falls into the same category. The reason the GAMs are nice is that predictions have this additive structure, which allows users to visualize the impact of a single feature. So you can see an example on the right here. You have one function corresponding to each feature, and you can visualize that function. Remember this because I'll come back to GAMs a little bit later in this talk. So the second common approach to intelligibility in the machine learning community is to design simple post hoc explanations for complex models. You may have heard of LIME or SHAP, and I would put those into this category. Many of these approaches work by approximating a complex function using simple local approximations, such as a linear function that can be easily explained. SHAP, which I'll also come back to later in this talk, builds on ideas from cooperative game theory to assign some notion of an importance to each feature, which is intuitively a measure of how much the feature contributes to an individual prediction. But despite all of this really cool research going on, there's still now a fair amount of disagreement in the machine learning community about what intelligibility means and how to measure it. There have been a bunch of position papers examining these issues, and as Finale Doshi-Velez and Bean Kim pointed out in their position paper, the machine learning community often has this "you'll know it when you see it" attitude. By the way, I should mention I'm using intelligibility and interpretability interchangeably in this talk. The difficulty of defining and quantifying intelligibility is compounded by the fact that there are different types of users or stakeholders, and these different users have different needs in different scenarios. So the approach that works best for a CEO making strategic decisions is likely to be different than the approach that works best for a regulator who wants to understand why some individual was denied a loan. And this in turn may be different from what works best for a data scientist who's trying to debug a model. Additionally, all of these approaches that I've mentioned so far have focused on intelligibility of the model itself. but depending on who our stakeholders are and what goals they may have, we may want to introduce intelligibility at other stages of the machine learning lifecycle, starting from the definition of the problem that's being solved or the data collection, all the way through to model deployment. So these concerns have prompted me to adopt a human-centered agenda for intelligible machine learning. I want to mention my colleague Hannah Wallach and I have recently written a book chapter on this agenda, and you can find that on my website. So if you're interested, you can check out that for more. Within the FATE group at MSR, we've been working on this agenda from a couple of different angles. So first of all, we propose that people should stop relying on intuition and instead empirically test which factors of a machine learning model enable users to better achieve their goals. In a few minutes, I'll tell you a little bit about some work we have in this space, examining how factors commonly thought to influence the intelligibility of a model impact people's use of the model. A second angle is to consider intelligibility beyond the model. So for example, intelligibility of data or objectives or performance metrics. And I'll tell you about some work that we have in this space, examining how the stated and observed accuracy of a model impacts people's trust in the model. Finally, we propose that researchers and practitioners design and evaluate methods for achieving intelligibility in context with relevant stakeholders. Here I'll tell you about some more recent work we have examining how data scientists perceive and use intelligibility tools and what that tells us about how we should be building them. Okay, so let me jump right into this first point. So to question our intuition about intelligibility and empirically test it, my colleagues and I have found it helpful to think about intelligibility as a latent property that can be influenced by different manipulable factors, such as the number of features in a model, whether the model is linear, the user interface of the model, and so on, and that impacts different measurable outcomes, such as a user's trust, a user's ability to debug a model, ability to simulate the model's prediction, things like this. Now, notice that all of these properties on the left are properties of system design, whereas on the right, we have properties of human behavior. Taking a cue from psychology, in a project that was led by Farooq Persavzi-Sengda, we designed randomized human subject experiments to isolate and measure the impact of these different system factors on fundamental properties of human behavior relevant to intelligibility. So the idea is to randomly vary these system factors on the left and then measure the impact of these properties on the right. While this may seem simple, in practice, it's really hard to do this while holding everything else equal. So in our experiments, participants were asked to make a prediction about the selling price of different apartments with the help of a model. In addition to a simple baseline condition in which participants did not have access to any model, we considered 4 experimental conditions in a 2x2 design corresponding to the 4 models that you see here. So I don't expect you to be able to read everything on the screen, but let me point out the differences between these conditions. Okay, so first, the models up top use 2 features, while the models on the bottom use all 8. Second, the models on the left are black box, whereas on the right, we have transparent linear regression models with weights that are visible to the participants. For these conditions on the right, we did explain during the training phase exactly how the models work. Now, crucially, in all of these conditions, participants see the same model input, that is the same apartment features, and the same model output, the same predictions. That is, we specifically chose apartments where the 2 feature and 8 feature regression models make the same predictions when rounded appropriately. So the only difference between conditions is what people see in between. This means that if we observe any differences in people's behavior between conditions, then we can safely attribute that to differences in the model. So this is important for our design. Okay, I'm not going to go through all of our studies in detail, but let me mention a couple of key results and implications and point you at the paper if you're interested in learning more. So first, we found that participants who were shown a clear or transparent model with a small number of features were best able to simulate the model's predictions. This is perhaps unsurprising, but it's reassuring to see in the data. However, we found that there was no improvement in the degree to which participants followed the model's prediction on typical examples, when it generally would have actually been beneficial for them to follow the model. Additionally, we saw that in some cases, too much transparency was actually harmful. Specifically, transparency reduced people's ability to detect when the model made a sizable mistake and correct it, seemingly due to information overload. So this was something that was really surprising to us. More generally, these results emphasize the importance of user testing and experimentation over intuition in the design and evaluation of intelligible models. They also emphasize the importance of the way that information is presented to users, which is, I think, is one place where expertise from the VIS community could really come in handy. Okay, moving on to the second direction, intelligibility beyond the model. Let me briefly mention some work of ours, which was led by Ming Yin, who's now at Purdue, that received a Best Paper Honorable Mention at CHI in 2019, and can be viewed as a study of the intelligibility of performance metrics. Okay, so in this study, we set out to examine whether models' stated accuracy on held out data impacts people's trust in the model. If so, whether it continues to do so after people have observed the model's accuracy in practice. And finally, how a model's observed accuracy in practice affects people's trust. So to do this, we again made use of randomized human subject experiments. We showed subjects information about pairs of people who had been matched through a speed dating event. Subjects were first asked to make their own prediction about whether a speed dating participant wanted to see his or her partner again. They were then shown a prediction from the model about the same people. And finally, they were given a chance to update or revise their original prediction based on what they saw from the model. They did this many times, completing 40 such tasks in 2 phases. So at the very beginning of the first phase, we gave people information about the model's accuracy on held out data. This is the stated accuracy. Then after the first phase, we gave them feedback on how they themselves had performed so far and how the model had performed so far. This is the model's observed accuracy. And at the end, we had them answer a couple of questions about their use of the model. In each of our experiments, we varied either the stated accuracy that they were shown at the beginning or the observed accuracy of the model that they saw at this midway point, or both. So those were our experimental conditions. Okay, again, because I only have a short amount of time, I'm going to skip right to the high-level results and implications and point you at the paper for more detail. So first, we found that the model's stated accuracy on held out data does affect people's trust in the model, which is reassuring. And specifically that they're more willing to depend on a model when its stated accuracy is higher. We also found that people put substantial weight on their own interaction with the model and the accuracy that they observe. And we saw this happen even though subjects had somewhat limited interaction with the model, as in they changed their behavior at this midpoint after getting information about how the model performed just based on these 20 tasks in phase 1. These and other results that we discuss in more detail in the paper highlight the need for designers of ML systems to clearly and responsibly communicate their expectations about model performance to users. We see that this information shapes the extent to which people trust a model, both before and after they observe the model in practice. And this is another place where I think that there could be really influential work from the VIS community coming in to help us. Okay, moving on to my final bullet here. I'll spend the next few minutes talking about some more recent research, looking at how we can evaluate the intelligibility of existing tools in context with stakeholders. And this is work that was led by an incredible summer intern, Harman Kaur, and received a Best Paper Honorable Mention at CHI 2020. So in this work, we're zooming in specifically on data scientists as our stakeholder, building models. In particular, we're interested in how data scientists perceive and use existing off-the-shelf intelligibility tools, what challenges these data scientists face, and what opportunities we as researchers have to make these tools better. Now, before I get into our study, I want to step back and just talk a little bit about why this type of evaluation is challenging. And I want to be super clear here that the reason that this type of evaluation is often missing from machine learning papers is not because machine learning researchers are lazy or they just don't care, but because getting this type of evaluation right is really an entire research agenda on its own. So first of all, it requires expertise in both machine learning and in HCI or psychology or other human-centered experimental areas. It requires knowledge of both the academic literature and day-to-day engineering practices of data scientists. It requires both qualitative analyses in order to understand the nuances of how people are interacting with these tools, and also quantitative methods to scale up findings. Any study should mimic a realistic data analysis setting as best as possible, but shouldn't be too cumbersome and shouldn't take too much time. And finally, it requires separating out the effects of the model itself, the intelligibility technique, and the user interface of a specific tool. So to address these challenges, we recruited a diverse team to work on this project, consisting of both machine learning and HCI researchers, as well as data scientists who have practical experience building and working with intelligibility tools in their day-to-day job. We also attempted as best as we were able to put these data scientists into a realistic context. And finally, we used a mix of qualitative and quantitative methods. So specifically, we started with pilot interviews to identify the types of challenges that data scientists face on a day-to-day basis that an intelligibility tool might help them with. We then ran an interview study to observe data scientists' ability to use interpretability or intelligibility tools when faced with these challenges. And finally, we ran a large-scale survey to scale up these results. So for the preliminary interview study, participants were put into context, in this case, working with real data, a real model, and a real intelligibility tool in a Jupyter notebook. We wanted to explore the use of both types of tools that I mentioned earlier, so both simple models and post hoc explanations. So we had half of the participants use generalized additive models or GAMs, these glass box models, and half use SHAP. Participants saw a tutorial on the interpretability tool that was based on existing published documentation, but with a bit more detail added. And then they explored a trained model, seeing visualizations from the interpretability tools. Finally, they answered a bunch of questions about the model. So each of the tools, GAMs and SHAP, provide three types of explanations. The first is local feature importance. So this is a description of how important each feature is for the prediction made on an individual data point. The second is global feature importance. So how important is each feature on the whole across the entire data set? And the third type of visualization zooms in on the way that a specific feature, so age in this example, impacts predictions. The model that we used was trained on a variant of the common adult income dataset that we modified in order to reflect the types of challenges that were extracted during the pilot study. So for example, in our pilot, we saw that data scientists often face problems due to the way that missing values are filled in the data. So before training the model, for 10% of data points with positive labels, we removed the age value and used the common approach of replacing it with the mean age across the rest of the data set, which in this case was 38. So this resulted in the model exhibiting these strange spikes like the one that you see here for 38-year-olds. Okay, so jumping right in, a couple of different themes emerged from the qualitative analysis of our interview data. So first we found that there was a set of participants who overused the tools, using them to justify cases where the model exhibited strange behavior. This led them to put too much trust in the underlying model. As one participant who was given GAMS said, age 38 seems to have the highest positive influence on income based on the plot. Not sure why, but I guess if that's what's shown, makes sense. Another participant who was given SHAP ran some tests on their own and then was willing to just accept the model's behavior when the tests agreed with SHAP's output. On the flip side, we also saw some cases in which participants underused the tools because they weren't confident about exactly what the tools were showing them. Another theme that emerged was the importance of social context. So in particular, participants seemed willing to trust what the intelligibility tools were telling them simply because these were publicly available tools. Okay, so just quickly to sum up these results, we ran a large-scale survey mimicking the interview setup as much as we could. We took advantage of having a larger pool of participants to run some randomized controlled experiments. We randomized two things. So first, as before, whether each participant used SHAP or GAMS. And second, to understand how people were affected by the content of explanations, we randomly showed half the participants a manipulated version of the global feature importance values, in which we showed less important features as more important and vice versa. Our qualitative findings on the whole were similar to what we saw in the interview study. I'm going to skip this because I'm tight on time and they were very similar. I'll just highlight a couple of our quantitative results. So first, participants had higher accuracy on multiple choice questions about the visualizations using GAMS compared with SHAP. And participants who used GAMS were also more confident. We found that manipulating feature importance values reduced participants' confidence that explanations were reasonable, which is good. But it didn't lead to increased suspicion about the model or the interpretability tool, which is not exactly what we would want. We would hope that showing them these kind of nonsense explanations would make them more skeptical. Okay, good. So I've told you about a couple of studies. I've argued that we need to design these intelligibility approaches that fit the needs of different stakeholders across all stages of the machine learning lifecycle. But what does this have to do with VIS? Well, the reason that I was really excited to be able to come and speak to this audience here is that the machine learning community really needs your help in this space. Now, most of the visualizations in these tools that I've shown you throughout this talk were created by machine learning researchers who don't have the expertise that you have. And frankly, a lot of the visualizations and tools that are out there are not great and can often be misleading. Now, if we want these tools to actually help stakeholders, we need to move beyond what information is presented to users, but how that information is presented to users. There's been a very small amount of work in this area already. So for example, my Microsoft colleagues, Stephen Drucker and Robert DeLine and their collaborators have done some work on improving visualizations for GAMS. But I would really love to see more dialogue between the machine learning community and the VIS community. And this is something that I would be very happy to discuss with people in the panel later in this session. So I will leave it at that. Thank you very much. And thanks again for having me.
Okay, thank you so much, Jen, for this amazing and inspiring talk. What a great way to start our second session. So we're a little bit behind in our schedule, so Jen will be available in the discussion panel at the end. I just want to ask one question from the audience. Natalia asked, should models indeed be intelligible? Humans are not. We do not know how other people solve problems or make decisions, but we trust them when they can provide convincing justifications of their solutions or decisions. Justifications are not the same as explanations of how people came to their solutions or decisions. So what do you think, Jen?
That is a great question. And I think there are actually a couple of different questions packed into that question. So first of all is the question of, do we actually need intelligibility at all? And there I would argue that we don't always, but we often do. And there are a bunch of reasons here. So one is, and the big one that I see in industry is that intelligibility is necessary for the people who are building models if we want them to be able to debug models and debug their data and just generally understand what's going on so they can fix problems. It's absolutely necessary there. It's also helpful for others involved in the process of building AI systems. So, designers who have to build interfaces for end users, for them, it's helpful to have intelligibility so that they actually understand what the model is doing and can present this to end users. It's useful for people who are being impacted by systems so that they can understand how and why the model is making these decisions about them. It has many different uses for many users. So I think intelligibility absolutely is necessary in some cases. But there was this other kind of question tucked in there about how explanations may not actually be accurately explaining what the model is doing on the inside. And this is definitely an issue. So many people in the community have come to the position that if you're in a really high stakes scenario where understanding exactly what the model is doing is super critical, then you should not be using these post hoc explanations, but you should be using glass box models where you can see kind of exactly the internals of what's going on. Anytime you're using a post hoc explanation, you do have this trade-off between the accuracy of the explanation and how clear it is. So, but it depends on the domain.
Okay, great. Thank you very much for your answer. And if you have time, you can jump into Discord. There are a lot of questions for you. But thank you very much. Great. So we'll see you at the end of the session for the panel. And thank you so much for your presentation again. Okay, so I think Emily will introduce the next speaker.
So it's my pleasure to introduce our next speaker. Vikas Chandan will be presenting on behalf of him and his colleagues at PNNL on their paper titled Towards Trust Augmented Visual Analytics for Data-Driven Energy Modeling. And this is a full paper with also an extended video available on the workshop website if you want to check it out afterward. So Vikas, feel free to take it away.
Hi, everyone. This is Vikas Chandan from Pacific Northwest National Lab here in Richland, Washington. And first of all, thank you so much for the introduction, and thank you so much for the opportunity to participate in this workshop. I think it's a great workshop from what I can see. This is also a new community for me. I'm a kind of a domain expert in the energy systems area. And it's good to interact with people in the visual analytics community. So that's really great. Okay, so this work is essentially a multi-institution collaboration, primarily led by Professor Aritra Dasgupta and his student Akshit from New Jersey Institute of Technology. And some of the other co-authors are my colleagues Soumya and Chris from PNNL, and Indras is from Lawrence Livermore National Lab. So buildings consume a lot of energy, and the building sector is responsible for around 40% of energy consumption here in the US and worldwide. And one of the key goals in buildings research is to reduce energy consumption. And an important enabler for that is to have models which can predict energy consumption accurately. So if you look at the field of building energy modeling, it has undergone a significant transition over the last couple of decades from more of physics-based or white box or glass box modeling approaches, which are resource and time intensive and also suffer from limited accuracy, to kind of more data-driven machine learning type of approaches. So there are a lot of papers out there which are focused on machine learning based modeling for buildings. And even the building operators actually have a lot of access to a lot of data, primarily because of increased automation in buildings. And the data is usually available to them through integrated dashboards and things like that. But then there is a significant difference or gap between the state of the art, what exists in scientific literature versus the state of practice. And what I mean by that is that the building operators are expected to take decisions based on what they observe and use their own training and experience. So there's a lack of decision support tools that can help translate the data into actionable information, actionable insight for the building managers. And not just building managers, but actually across all the different stakeholders in this domain. So that is kind of the setup for this work. And to give a little bit more detail here, so if you look at a typical building energy modeling problem, the outputs are consumption variables such as whole building power consumption or energy consumption, and measurements such as zone temperatures, which are an indicator of occupant comfort. And the inputs are control knobs such as set point temperatures, things that you can change, and things that you cannot change, for example, the outside weather. And then these models are then, they can be used to reduce, address different use cases such as reducing energy consumption by converting them into appropriate optimization problems. I'm not going to go into details there, but those are available in the extended video. And this is a domain which has several different stakeholders, building operators, utility companies, policymakers, occupants, and modelers and researchers. And each of the stakeholders have their own needs, which may or may not be aligned very well. So some of them can actually be in direct conflict with one another. For instance, if you look at building operators, they are trying to minimize the energy consumption. They're also trying to maximize occupant comfort. And these two goals essentially don't go hand in hand. And then also the goals for different stakeholders also might not be very well aligned. So this is just to give a sense of the complexity that we deal with in this domain. Focusing on a particular stakeholder group, which is very important, is building operators. So building operators, their primary goal is to make sure that the buildings are comfortable, the occupant complaints are minimized, and therefore there is this 330-300 rule, which is often used in this community, where which says that the cost of not meeting people's comfort needs can be a couple of magnitudes higher than the cost of operating the buildings inefficiently. So therefore, building operators tend to be more focused, you kind of have a more conservative approach, just focused on maximizing comfort. So any new technology, such as machine learning, can be viewed as kind of a new technology which is opaque, where the working mechanism is not clear, and the operators are not sure what impact it will have on the occupant comfort. And therefore, there is an inertia to move away from rule-based techniques that they are used to use. They're well trained in those, and they're also very intuitive. So this is a primary challenge, a primary reason why we see that gap between the state of art and state of practice that I mentioned. And we believe that visual analytics can help address that, and can help bring building operators together as partners for technology penetration. Another stakeholder group is people like me who are developing models for building energy consumption. So we have an example here from a project at PNNL where we compared different machine learning techniques applied to data from a particular building. And we found that deep learning based models outperformed the other machine learning techniques when we just focus on a metric such as MSE. But then when we look at the time trace, we see that, well, actually the deep learning based models do very well on an average, but then they're not able to capture the peaks very well. So this drives home the point that metrics-based evaluation of machine learning techniques can be inadequate. And a lot of visual inspection is required, which is a manual process. And again, this is where hopefully visual analytics can help. So next, we look at this interesting problem of real-time actionable inferencing for building operators. So in particular, we are looking at a multi-criteria decision-making problem where building operators are asking questions, such as what happens to energy consumption if the temperature set point is increased. And then these are essentially what-if variants of prediction problems, where the challenge is that there are multiple goals, and the goals can be competing. For example, we are trying to minimize energy consumption, but at the same time also minimize occupant discomfort, or maximize grid service provision while also maximizing system reliability. So, so I gave kind of in this short presentation a flavor of different problems that affect different stakeholder groups. And then here is a summary of kind of our vision for how visual analytics can help address these challenges. So visual analytics techniques, in particular comparative visualization, can really help with these decision-making problems by improving explainability, trust, and transparency. And in particular, they can help in synthesizing and explaining the multi-criteria impacts of the decision choices. For example, what happens if you increase temperature set points or switch the lights? And also they can help compare the impact of the relative priorities on the multiple criteria on performance. And hopefully through all of this, it can help us earn the operator's trust on the model outputs. So this is our vision represented in an infographic. So essentially, we are talking about visual analytics for energy modelers, where the focus is on kind of developing models efficiently and making sure that the models are still able to provide accurate performance. And the other aspect is visual analytics for operators, which is focused on kind of breaking that trust barrier between the state of the art and the state of practice. So there's a lot of detail, and I don't have time to go over this, but you can look at our paper if you're interested, or the extended video. So essentially, we are looking at a framework where building energy modelers are able to answer questions such as how can the training data be configured better, which models are better, and compared to others, and then how robust and stable are the models. And then for the building and the grid operator community, hopefully this can help answer questions like what is the predicted thermal demand of buildings, and then also help them decide what actions should be taken for balancing different needs such as occupant comfort and energy consumption. So I know that this was a lot of information packed into a few minutes. So I'll stop here. And I just want to say one last thing. So this is, we are not showing any results here. This is more of a shout out to the community to essentially show that we can, I think, by collaborating between different experts in visual analytics and experts in machine learning and domain experts such as myself, I think we can hopefully address some of these challenges that are faced by this community. So I'll stop here and thank you so much for attending my presentation, and I look forward to any questions.
All right, I want to thank Wikus for his great presentation. We couldn't have time for the Q&A right now because we're a little bit behind the schedule, but please feel free to ask questions on the Discord channel. Our next presenter will be Austin Wright from Georgia Tech, who will be presenting a work in progress, titled A Comparative Analysis of Industry Human AI Interaction Guidelines. It's a great work. We're excited to have him here. Thank you very much, Austin. We're ready whenever you are.
Hi, everyone. I'm Austin, as I had the great introduction. I'm a PhD student at Georgia Tech, and I'm here excited to show you this work that we've been starting on and not quite finished, but we thought we'd share it with y'all anyway, on a comparative analysis of industry human AI guidelines. So in the past year or so, a lot of different companies have come out with their own proprietary sets of AI guidelines, from Microsoft and Google and Apple, all having their own publications on how best to build machine learning products. Now, what we feel like is that ultimately these are trying to understand what the best practices are in building AI products, but best practices aren't determined by just a single company, really. They're determined by the synthesis of the whole industry. And so that's what we've done. We've tried to compare and contrast and build a survey of what these current publications are telling you about AI interaction. And we put that in a single centralized reference for developers. So first, let's kind of walk through what the different publications themselves say. So in May of 2019 at Chi, Microsoft published their guidelines for human AI interaction. And what this work really presented was a really nice user-centered design process of coming up with these guidelines. And so it started with 168 sources from academic and industry sources. And what they did is they refined them down into 18 very specific forms of guidelines that are kind of like a single sentence to keep track of. And then it organized them over the course of what a user would see initially or during an interaction or over time as a product learns. And then what they did is they validated their findings with a user study of AI practitioners to find what were the most applicable, and then they iterated on these guidelines. Then at the same month, Google came out with their People and AI Guidebook. Now, their approach to guidelines was somewhat different than Microsoft's. It contained 113 guidelines, and so they didn't really do as much of the cutting. They had a very large database of guidelines. And while they did have sources to academic literature, as well as internal sources, they didn't do a kind of user study. It was more of a publication of what they think are the best ways to build them. And they included worksheets and other things that would be useful for a developer. And in fact, their structure was, instead of outlining when a user would notice any of these guidelines, it's when would a developer care about them in the process of building a tool, as opposed to a user interacting with the tool. And then finally, later in 2019, Apple came out with their human interfaces guidelines for machine learning. And this was probably the most different out of all of the ones that we've talked about here, in that it contained 59 guidelines, but it was really more of a form of practitioner knowledge. None of these really had extensive citations to other kinds of literature. It was kind of institutional values of Apple coming forth as what they value when building their AI-driven products. But this is kind of a useful difference, you know, when we're combining all of these things, different perspectives would help us understand the full breadth of important guidelines. And so they had a more of a UI UX focus. So then what we did to try and build a unified structure from all of these disparate sources of AI guidelines is we took all of those individual statements from these different sources, broke them out and filtered out some of them that didn't mean very much outside of the structure that they were presented in. This gave us 194 different guidelines that we then broke out and sorted in a card sorting exercise, really in the same methodology as what Microsoft did with their sources, except we had only industry sources. And we grouped them together into similar themes, and then those themes together into higher level categories. And so these categories, for instance, would be about confidence displays and a lot of different guidelines on how to display confidence in a model. And so this gave us this structure here. So we had 4 high-level categories of initial considerations, the model, deployment, and then the interface. And then these broke down into smaller subcategories, and then the guidelines themselves. And so, you know, there's the value of AI, fairness, and privacy. These are the things that you want to keep track of as guiding principles before you start building things. Then there's the model specifically. So when you're having training data or the training process of the model, things you have to keep track of. when you're collecting or using feedback after deployment of a model, and then similarly making sure you are preventing or mitigating different kinds of errors. And then the largest one here is interface guidelines. And this is probably the set that's the most overlap with visualization, but we'll talk a little bit more about visualization at the end. So building out mental models is something that seems to be very important, explainability more generally. And then there were some more specific ones in particular about giving users multiple options based off of a probabilistic model from an AI, showing confidence and then having good calibration experiences. Now, this allowed us to then compare the relative emphasis that each company gave to each one of these categories. And we find a couple of big things, notably that Google really outsized focused on the model compared to the other companies, whereas Apple and Microsoft didn't as much. And other than that, the interface and deployment categories were the primary drivers. Furthermore, when you look at the low-level categories, we find that Microsoft spent 40% even just on emphasizing how to best build mental models, whereas Apple had these like very specific things like enforcing multiple options and error prevention based off of having a smooth user experience, which really seems to us to show that the methodology, whether that's a user study kind of validation or your specific institutional values, inform what you think is important when you're making a publication to say what's a kind of guideline for building a tool. Now, given that, what we thought was that these companies might have these values that differ from people that aren't part of some very large company. And so then we worked on building out this AI open guidelines, which is an open source repository of all of these survey of guidelines that we saw from here, but then is now open source so that users can further the building of the best way to build AI systems, but on their own in an open source manner. So like to thank y'all for coming and watching this. Hopefully we stayed it as short as possible. And you can head over to that URL to help contribute. We'd really appreciate it. And I'll help answer any questions.
Thank you, Austin. It was a great presentation, and I feel like your work is very valuable for the future research because there's no simple, standardized guideline book for every person in the community. So great job, and we look forward to the extended format of this work in the future. We don't have so much time for the Q&A, but I'm pretty sure you're gonna stick around for the panel at the end. I have one question for you, which should be quick. I realize that you said your work is kind of open source and you want people to kind of contribute to this work. So can you please explain for the audience how they can do that? And
so if they just head over to that ai-open-guidelines.readthedocs.io, you can see all of the guidelines that we've conglomerated, and there's also a link to the GitHub repository that hosts it. You can just submit a pull request. There's instructions there to make it as easy as possible. Ideally, as things move and change, we can keep that updated. And again, it's open there. Also, fun fact, I don't know if any of y'all noticed the invisible gorilla that I added to one of those slides after the initial talk today. We'll leave that as an exercise to the reader to see if any of y'all remember what slide I put that on.
That's great. Thank you. So very fast question. Since this is a work in progress, where do you see this work going in the future? Or how do you want to expand?
Yeah, there's a couple of things. The most interesting to me is is adherence, right? So we want to see how these companies or other people actually adhere to these guidelines that they propose, right? They say people should be doing this. Now let's look at what are all these different AI systems that are out there in the world and how well do they actually adhere to these guidelines? Some of them are very vague, and so it's hard to measure, and some of them are very specific that we could look at. And I think that's a really interesting route that we're looking at going on. And then there's also other companies that have since published, like IBM has another big one. So we also would want to expand that as those get more published.
Great. Looking forward to it. Good luck on your future work. And thanks for being here. So now Emily will present the last paper of the session, and everyone, please stay tuned for our great panel at the end.
It's my pleasure to introduce our final speaker. We're really excited to have Adam Kosia joining us today, presenting his paper in collaboration with Polo Chow and Alex Endert, titled Toward a Bias-Aware Future for Mixed Initiative Visual Analytics. This is a work in progress paper, and you can go view the full text on the workshop website. So Adam, please.
Thank you, guys. So I'm Adam Kosia, a first-year PhD student at Georgia Tech, advised by Alex Endert. And our paper contributes open questions and opportunities surrounding cognitive bias awareness and mitigation in mixed initiative visual analytics systems. So first, I'm going to motivate our focus on mixed initiative approaches, particularly in how they guide users in existing domain applications. This is going to set the stage for identifying where we can take initiative in visual analytic design towards addressing cognitive bias, leading to a larger discussion about questions and challenges realizing this future. So why mixed initiative? It's a set of user interface principles, and it's all about balancing human and machine efforts, but specifically, they encompass both recommending and intervening strategies. We think this is really important when we consider guidance in the visual analytic process, especially since visual analytics is used in a lot of domains like urban computing and national security. So we looked at this interdisciplinary research, and we found ways to engage with this bias-aware design through a mixed initiative approach. And this led to finding opportunities to take initiative, first being this systematic interpretation of cognitive processes. We found examples of machine learning driven by domain knowledge, and they used mixed initiative principles. We also know that there's models out there for interaction tracing in visual analytics. We coupled that by knowing that there's been proven manual provenance tracking that's been used to mitigate cognitive bias in non-technical ways. And so we see a huge opportunity here to interpret these cognitive processes systematically in the system itself towards addressing cognitive biases. And we decided to look deeper at this provenance data, right? Specifically where it appears in the analysis process and how it affects decision-making and visualization. And we found more examples of encoding and presenting interaction history to users, highlighting a great opportunity to promote awareness and reflection of personal bias. And so we can both interpret and encode these interactions for provenance-driven feedback, but how do we guide the users with this analytic provenance? And once again, we answered that by looking towards interdisciplinary research, and we found that the user process was the key element there in guiding the users, and found it specifically in visual analytic applications in national security. And this revealed to us that there's a need here for computational metrics in the system, and there's an opportunity to develop them. But so we stopped and thought about it for a while about these opportunities, right? And we realized there were a ton of questions and challenges that were popping up facing this future. And so many so that we split them into two broad ideas. The first being, well, how do we reconcile diverse goals with mixed initiative approaches? So first consider creating a visualization, very basic, with a system like Tableau, which is going to use traditional fixed heuristics for recommendation, like a show me feature. And it's easy enough for us to say, well, let's find ways to mitigate bias in that process of using these recommendations. But what is it going to take against those fixed heuristics to implement something with bias awareness interactively? That is, when we go further to have real-time metrics for this iterative mixed initiative workflow. And let's say we look at mixed initiative more closely. Even there, bias mitigation may not be the primary consideration. Let's say you use visual analytics to improve prediction or improve your clustering models, right? Well, is bias mitigation going to get in the way of that goal, right? Are you going to have to choose between a more accurate model or a more fair model? And implicit in these two ideas are domain needs. I mean, these are real users we're talking about that are taking advantage of visual analytics. Well, how do we communicate to them that they might be biased and that taking 30 seconds even to explore more data before making a decision might have some real benefit? But what does the goal become then? Does it become bias mitigation? Does it become better models? And if it's not productivity, then what are we aiming for here? So it's not just about let's mitigate bias and let's build trust in our systems. We're going to have to balance these goals somehow. And I think this dovetails beautifully with honestly all the talks we've just heard, right? All these incredible researchers collaborating and using VIS to address uncertainty, trust, explainability, interpretability, intelligibility, a lot of abilities. We see each tackling this balance in healthcare, machine learning, cognitive research, artificial intelligence, right? And they're all looking towards visuals and visual analytics for the future of their work. And in each case, the tool, technique, or system was human-centered. The goal determined the guidance that their approach took. And let's say we consider the previous example of model accuracy as our goal. You'll still have those fixed heuristics that we talked about, right? They still work really well in that case. But let's consider a system that also has bias metrics in it, right? What happens when those metrics might suggest or even force a user away from the goal of the heuristic, right? Away from, let's say, a more accurate model. And in that vein, will the interactions that bias metrics look for be similar or even interpretable to the existing systems that are in these domain settings? I mean, what happens when you trace these users' interactions? Let's say we examine users interacting with visual analytics for criminal analysis. What are we going to find in their interactions, right? And when we do find existing ways to incorporate cognitive bias awareness in those interactions, how do we tell those users they're being biased? I mean, we discussed that they're raising user awareness of personal bias helps in the analytic process. And I think this is where mixed initiative really starts to shine, both recommending and intervening in user interfaces to help with decision-making in domain settings. And this has given us a really big opportunity to engage with domain-specific research and bring other communities into the VIS space. I mean, we're currently looking at cognitive research to help us figure out how to balance these goals. How do we let the system recommend? When do we let it intervene? And how can we improve this analytic process using mixed initiative visual analytic systems? So if all that sounds a little familiar to Emily's work, it is, because it is a large extension from stuff she's identified from the beginning. And I'm really thankful to her that I can continue this work. And if you're really interested, look us up at Georgia Tech, or there's my contact. So thank you, everybody.
Thank you again, Adam, for the great talk. We're really, really excited to have you here with us today. So you mentioned in your paper this spectrum of more awareness-based forms of bias mitigation to more active initiative from the system. So I was just curious if you could talk a little bit more about what you see are some of the factors that can help a VIS system developer decide where they should fall on this spectrum. What kinds of things come into play that might lead me to choose a more active approach versus just trying to sort of increase users' awareness?
Yeah, so I've definitely started this taking a lot of hints from existing work that we've worked on here. And I think in a lot of those, it was driven by looking at, as I said before, domain examples, right? What are the needs of the users and how did they interact with the system? And that's where engaging with things like decision-making research led by cognitive researchers or looking at national security with criminal analysis. I think part of our team really believes that that's going to be a major factor, independent of what we develop and decide might be an approach, right? Making users aware with like a pop-up window or actually intervening and say, no, you can't interact with this data, it will be biased. That I think is going to be driven by what existing fields say they need out of their data and out of their analysis needs.
Yeah, that's a great point. Thank you. Yeah, so I think to try to stick a little bit close to time, we'll transition next to the discussion panel. So please stick around and put any questions that you have in the Discord channel.
Thank you everyone for your amazing contributions and papers presentations. This is the final discussion panel and we are so excited to have everyone here. Please feel free to contribute to any of the questions and answer whichever you want. We just want to have an engaging discussion for this panel. Also for the audience, if you have any questions or that you want to be discussed here, please use Discord or YouTube. So the first question that we have for our panel is, there are many different places where we can be working to build trust, such as the data itself, in model calibration and in communication. If time and resources are generally limited, can you speculate where you see the biggest potential for impact? Maybe we can, okay, Jen, please.
I'm happy to answer if nobody else wants to jump in. So I think this is a good question. I think first of all, it depends on who it is that you're trying to build trust in, because there are different stakeholders you could have in mind here with different needs. But in general, I see a huge opportunity in data and building trust in data. This is something that I just see on a day-to-day basis within Microsoft. So first of all, thinking about developers who are building machine learning systems, there are so often problems with the data. I mean, I have a colleague who likes to say that every data set is flawed, and essentially a lot of what you're doing in building a model is just trying to find the flaws in your data. So a lot of the work that we have done like around intelligibility tools that I mentioned earlier has been for the purpose of helping data scientists find problems in the data and fix those so that they can build more trust. This also relates to other initiatives that I've been involved in, like the data sheets for data sets project, which I didn't have time to mention in my talk, but this is basically a project aimed at having better documentation for data sets, so that the people who are building models based on data sets or using models that have been built on data sets can understand where this data is actually coming from, and so on. I just think there's a kind of a huge amount of opportunity there. Oh, you're muted, Mahsan.
Oh, sorry. I just wanted to say thank you. That's great. And I said probably Dustin wants to say something.
Sure, I can jump in and add something. So I think there's kind of two parts to this question, and one is around what you do in sort of like a constrained resource situation, potentially where maybe you're a researcher and you don't have a lot of time. And I think in that particular case, you really want to focus on two things, which is the user and the domain that you're trying to help with. And so really identify who's going to be using the thing that you're trying to make, that you have a few resources to make, and how are they going to use it? What's the broader workflow that you're helping? A good way to waste resources is to build something in a vacuum and hope that you can find uses for it later. So we all like doing that. It's fun, but identify the problem first if you don't have a lot of time. I think the second half of the question that I could address potentially is that we can. So I talked about explainable AI, and that's certainly not the only thing that we talked about during this panel, but I'll talk about that again. We build explanations for a couple of different reasons. And so one is sort of for validation and debugging, in which case we're hoping eventually the thing that we're explaining is going to automate some task. But the other thing that's a little bit underexplored is explanations for insight. So instead of a traditional visual analytics kind of data exploration workflow, explanations can be used to actually get scientific or domain knowledge in an area where that doesn't already exist. And I think that's a little more unexplored or underexplored than the automation case. And so that's where I would potentially see investing resources.
Great, thank you. So anyone else who wants to contribute, or should we move on to the next question?
Can I chime in a little bit from a domain perspective? So yeah, I completely agree with what Jen and Dustin mentioned. For somebody like myself who is more of a domain person, so most of my work is in the buildings domain. I think I think there is trust to be addressed in all of these different areas. But I think if you focus on, if you're constrained on resources, the one thing that is really important in this domain is communication. And especially the gap, there's no lack of papers, which, every week I see 10 papers which are focused on machine learning for modeling, and they're claiming that they have this algorithm, or maybe they have enhanced a particular algorithm and they have tried something on a new data set. But I think the building if you look at the state of practice here, the operators who operate these buildings, they're still using tools from the 1960s and 1970s. So I think there's a lot of work that has to be done there, and the main reason why we see this gap is lack of trust. Yeah, so it's good. This is something that we will try to address through our collaboration between our institutions that I presented in my work.
Thank you, Vikas, for sharing this with us. So I think we should move to the next question. Oh, did we move? Okay. So this was actually a personal question that I have, and I think it was interesting because I think there's a gap between the machine learning community and the ACI community with kind of the evaluation metrics that they use. So I want to see if any of the panelists have any suggestions on making the gaps smaller between these evaluation techniques between specifically machine learning and the ACI community. What I was personally thinking is, are there currently any metrics that are focusing on iterative improvement of a machine learning algorithm or system using both sides of the spectrum, both AI and ML and ACI people?
Happy to jump in again if nobody wants to start. So the first half of this question is something that I've been thinking about a huge amount in the last couple of years. So my background is in machine learning and, you know, not even in applied machine learning. I come from the far theoretical end of machine learning originally. So I spent a lot of my career like writing proofs and designing algorithms and things like this. And it's only when I started working in the space of fairness and intelligibility and related problems in the past couple of years that I've sort of realized the importance of human-centered approaches and how big of a gap there is between the work that's going on in the machine learning and HCI communities. And I think that this is not something that is easy to address without actually having people from these communities take the time to come together and learn each other's languages, learn each other's values, and really start collaborating. And these days, you know, the past couple of years, I have worked directly with HCI researchers in a majority of my projects, and I still feel like I'm learning new things all of the time in terms of, you know, even just how to approach problems. Like in the machine learning community, there's so much of an emphasis on building systems just because we can and not actually asking questions around whether this is something we should be designing or how should we be designing this for users? Is this something that's even needed? And I found this really valuable, but it does take putting in the time and putting in the work and reading papers from other communities, learning to talk to other people. And I think the more that we can encourage real interdisciplinary work and have more venues that bring together these communities to talk to each other, venues that accept research that's at the intersection of these areas, because it can actually be kind of hard to publish research at the intersection. There are not a lot of people qualified to review it. And all of this is really necessary if we want to move forward.
Actually, Jen, I have a question about that. So what do you think about some of these recent changes to, I'm thinking in particular, NeurIPS added their impact section, right? And there was a lot of, you know, talk about that. And that kind of gets a little bit towards incentives within machine learning to think about impacts on people and everything like that. I don't know how successful that was necessarily on bringing these two ways of thinking together. And I don't know if you have any thoughts about how those kinds of approaches are successful or ways to do it better.
Yeah, that's a great question. I've been following this, but I don't know. I think it still remains to be seen how good of an idea it was to do that this year. I think that this was a step in the right direction. Requiring that authors think about the broader impact of their work more and actually explicitly write this down. But it's a bit of a culture change is necessary to get to the point where machine learning researchers are actually able to successfully do this, right? Like the problem is we can ask people writing machine learning papers to speculate about the broader impact, speculate about possible misuses and all of these other things. But if you're trained in machine learning the way that we currently train people in machine learning, you're not necessarily going to be in a position where you are able to do this properly. And the typical people who are reviewing machine learning papers aren't necessarily going to be in a position where they can assess these statements properly either. NeurIPS did make an effort to bring in like a special panel of ethics reviewers to try to address this. And I think at least in some cases, this was successful and caught some papers that, you know, that might have slipped through the review process otherwise, but I don't know. I think it's a good first step. I think there needs to be a lot more research and examination of how this worked this year, which I think is going to happen. And it's just going to take time and be like big culture change.
So I can make another suggestion to, I think on the cultural side. So ACL, so the Language Machine Learning Conference, and AAAI and NERPS, they all have demo sessions, and you can write short demo papers. And I feel like rather than, raising our arms and saying, hey, look at our community, it's so awesome, you should come join us, we can go to them too. And we can pretty easily get our work accepted there, I'm sure, because of the high quality of our work. And we should be doing that. And when you're writing a paper, really think about what audience do you want to influence, and do you want to influence the people that already know about you, or do you want to influence new people? And so potentially consider going to them. And that's one thing that we can do. I also am sometimes concerned about kind of the double-edged sword of how the machine learning community approaches evaluation in general. So, and this is how it's been taught for decades, but basically you come up with a well-defined task and you have these really well-defined metrics like F-score for understanding how good your model is. And that's great for reproducibility and accuracy and benchmarking, but it makes you basically put blinders on. You don't really think about the broader impact or the larger workflow of how this thing is being used. So an accurate model can be just completely impractical and can completely fail in the real world, and yet can be lauded as like state of the art in research. So I think that is a real concern, that our perspective as visualization researchers, where we think about the user, we think about the broader workflow, can really help, hopefully, if people will listen. But again, to my first point, we probably have to take it to them instead of ask them to come to our community.
Yeah, that is a great point, actually. So I think that, I'm a PhD student, so I think I should keep that in mind to just go to different venues as well. Cool. I think we should move on to our next question. Okay, so we often talk about trust as a one-way concept in visual analytics, of the human trusting the machine. What does it mean to consider the opposite direction of the relationship, for the machine to trust the human? I actually wanted to kind of point out Dr. Alexander, who were very nice to join us today for our panel. So if you have any comments on this, please, we would be love to hear from you.
Yeah, sure. Thanks for having me. I think it's an interesting extension that pushes us as or maybe the HCI community more in general, to sort of think about what usability means when perhaps systems start to question users' interactions, right? We all sort of come from the line of research that says, user control and control panels, and if I say do this, then the system should do it. And I think we all agree that that's actually a good route to go, generally speaking. But just as though, models need to take into account data quality, I think maybe it's time to think about interaction quality as systems start to, learn from people and so on. And I don't have a lot of advice for really what that means, other than I think as these two pieces come together and we bridge this gap of HCI and AI, or HCAI as some folks might call it, I think these questions are going to start to come up about what do systems do with user interactions from people that may not have the full intentions or goals in mind of fairness and bias and accuracy and all these things, right? Because they're all important, and I think we as people, like Steve and others earlier talked about, might need systems to help us understand all those facets, because we might be sort of directed towards just one of them.
Great.
Yeah, I was just curious. This seemed like something that's really relevant for the position paper with Adam, that if we're going to have machines that are more actively doing something on behalf of the user, then this bi-directional relationship seems a lot more important, right? The machine needs to know which input from the user is valid, and do we just assume that the user is the the final authority on everything, or perhaps there are some things that the machine is better at, and maybe, I don't know, to me, this question just seemed like an interesting thought experiment. Like I don't really necessarily know what it means to have this bidirectional relationship, but it certainly seems like something worth thinking about as we start to consider these more active approaches for bias mitigation or trust calibration and things like that.
And I'll say just quickly that being new to this area of VIS and saying not having the predisposition of VIS is the way to go, where the machine is answering to the user, even by asking this question, it spawned more questions. So in writing this paper, it almost forced me to consider it. And I think that was one of the most helpful ways to actually address it, asking the question and trying to base it in, well, what are people currently doing? I found that to be really helpful from a non-expert VIS perspective, right? So it didn't take VIS to know how to think about this.
Okay, great discussion. I think we have more questions and we need to wrap up quickly, but I'm personally really interested in this discussion. So can we move to the next question, Emily? Although we're running out of time, I'm just trying to go through all the questions fast. So there is a lot of inherently social language used when we talk about trust between human and machine. So like, for example, trust, trustworthiness, even forgivability. What do you see as the role of social sciences when we are discussing these issues in a computer science or visual analytics context?
So I think this actually relates a little bit to the previous question, or I'll try to relate it. But I think one area where it's interesting is when you're getting into the area of human-machine teaming. And so the AI is actually more of a teammate and less of just like a thing that you control. And then you can think of questions like communication and the etiquette around that. And so we can learn from the social sciences about etiquette and apply that potentially to that situation. And so, you know, an interesting sort of follow-up thought experiment would be, well, what would you like the computer to say when it's not going to do what you want it to do? Think about where or what that feels like when you're in a teaming situation with actual people and they do that. So like, for example, Alex asked one of the students to do something and they're like, yeah, no, I'm actually going to do this because that makes more sense. What's the etiquette around that? And can we have the same thing in like a machine teammate?
I have a slightly, very different answer, which is, I think that one place where we could learn a lot from the social sciences here is in terms of measurement. And what I mean by that is trust is such a fuzzy concept. And I've actually started shying away from using the term trust in my own work because a couple of times we've use the term trust in one precise sense, just to have people kind of like jump on us and say, that is not what trust is. You should not call that trust. And people have very strong opinions about what is and isn't trust. But it is something that is complex and has all of these different facets. And there are many different metrics that could be designed to measure different aspects of trust. And it seems like one place that we could kind of lean on the social sciences is through looking at how they think about measurement and what are we actually after when we talk about some concept like trust.
Yeah, I might almost push back from the other direction a little bit, I guess. I think the impulse as computer scientists is to quantify everything, to operationalize a definition of everything. And perhaps, I mean, just to play devil's advocate here, maybe one thing that we can learn from the social sciences is that maybe these things are far too complicated to attempt to accurately capture. In trying to do so, we lose so much information about, what it means to trust a system or what is bias. I mean, I've thought about this with my own work, certainly. The act of trying to simplify something down to a quantifiable measure seems nice in theory, and in practice, it just discards so much information that is potentially valuable and rich about, these interactions.
I don't think that's actually in conflict with what I'm saying. So, I mean, I think there is this impulse as computer scientists to try to come up with a metric to capture everything. And what we need to do is just get more crisp about what we're actually measuring with our metrics and what we're missing.
Yeah, that makes sense.
Yeah, these are great points. Also, I think Jen's view is kind of similar, or kind of reminds me of Dustin's paper in this workshop. They were kind of arguing that we shouldn't use trust as a measure for evaluating machine learning models, maybe use other metrics. So yeah, it's interesting to see these kind of relations. I'm really excited that we are actually having these conversations, because I personally feel like all of these are connected, and as a community, we need to try to figure out this huge bulb of, untangled, topics that none of us basically know what's going on, and we need to sit, in my opinion, we need to sit and discuss and see how we can connect them, and maybe as a community, we can build a better mental model of everything. So I just find it interesting. And yeah, I want to quickly go to the last question of the panel before we end this session, although I'm really sad that it's ending. I just feel like the discussions are awesome. So with, in the visualization community, one of the main focuses in explainable AI has been global visualizations where, for example, there are attempts of representing neural networks in through visualizations like trees and etc. But I think what I haven't seen so much is other visualization techniques or methods that can be used in globally, explaining the model. So anyone has any thought on how we can improve that, or focus on these and build a better global explanation other than the current existing approach?
So I know I've been talking a lot, so I'll jump in really briefly and say, check out our paper that hopefully will get accepted at ACM IUI 2021 on example-based global explanations. And so the idea is to take example classifications and use data analysis and clusterings and things like that to select sets of examples that represent the global behavior of the model.
Great, I'll make sure to check that out. Anyone else? I don't know if anyone has any comments, but okay. I guess there is at least one other work that I've seen from, I guess, Fred Hoffman from, Georgia Tech. They had some sort of more global visualization of, how to explain some metrics about the model and performance. I don't recall the name exactly. I can search it and put it in the chat. But other than that, I haven't seen anything in the community of visualization, and I would love to see more work in my, at least I would love to see more things in that area as well. All right, I think with that, we want to stop our discussion because we are all already over time. Thank you everyone for joining us. Special thanks to all of our panelists and presenters. We'd love to have you here, and the discussions today were great. All of our accepted papers and presentations are on our workshop website, so please make sure you check it out. And we are still having a Discord chat over the week, so please, if you have any questions or you want to continue the discussion, please join there, and let's keep the conversation live. And yeah, Emily, do you have any closing remarks? Anything you want to say?
No, I think we'll be online, still monitoring Discord and keeping the discussion going. But yeah, thanks everybody for joining us.
Thank you.
Thank you to the organizers. This was great.
Yes, thanks for organizing. Take care. Bye.
Progressive visual analytics provides intermediate results in the middle of computation to address a long computational delay. However, such intermediate results are uncertain, so findings from these results can turn out to be incorrect for the entire data. In progressive visual analytics with safeguards, we suggest to risk the uncertainty, but we allow humans to leave safeguards every time they risk the uncertainty.
How can we sample multivariate data such that we can preserve as well as utilize the variable relationships? For that, we first partition the data, and then for each partition, we perform PCA to model the variable relationships, and followed by sampling to reduce the spatial resolution. We can then perform different multivariate post-hoc analysis directly on the reduced data form.
How do you visualize the nanoscale, 1 billionth of a meter, for the public? As part of a Science Center exhibition, we developed an immersive environment that explains nanoconcepts by allowing users to explore nanoproperties. We reflect on how exploration, the confluence of explanatory and exploratory visualization, can be applied to visualization in public spaces.
Do these three essays construct their argumentation similarly? Where in this table of argumentation data from the previously seen texts can I find certain argumentation patterns? Do these three argument maps depict the same argument? We have developed a visual analysis system for argumentation in essays that can answer these questions at a glance. You want to know how it works? Come to my talk.
We demonstrate that people can use the spatial cues available in virtual reality to help them effectively remember and recall scholarly articles. We used a virtual coffee shop and asked participants to remember 4 abstracts from scientific publications, and we termed this method a virtual reality memory palace variant.
We present a method for real-time ray tracing of stream tubes for fluid flows and diffusion tensor MRI. Rays are traced through a sparse voxel lock tree until they intersect leaf nodes which contain tube segments. This checkerboard pattern indicates voxel boundaries. Within leaf nodes, we can ray trace straight tube segments or ray cast curved tube segments.
Data videos are quite popular nowadays. They usually show changes in the data. However, creating a data video requires multiple skills, and the process is usually laborious and iterative. Our approach focuses on automatic and interactive visual enhancement of important changes in time series data with data video.
This is a picture of a Tableau visualization within the browser. The data behind the visualization does not exist here, and Tableau is not running. This is just an image. However, parts of this image are fully interactive. Please join our presentation to see how we can share interactive visualizations across the web, free from any dependency on data or visualization application.
Program developers spend significant time on optimizing and tuning applications. But working with binary code to understand what compiler optimizations were applied can be challenging. We present our visual analytics system, CCNAV, designed to identify and assess compiler optimizations in binary code. Check out our paper to learn more.